Hello, welcome to another stream. How about that? How about that? Welcome, welcome, welcome. So today is Saturday, not Sunday yet. And that means today, according to the schedule, we're supposed to do something. But yesterday we had a very interesting topic and I slightly underestimated my programming capabilities. So I didn't finish everything that I wanted to finish yesterday. So I sort of shifted, performed this small switcheroo on the schedule. So today we continue doing the same topic as we did yesterday. So essentially, here's the idea. We're going to do genetic programming today. Tomorrow we're going to do something, and on Monday we're going to do something again. Usually on Monday we do code reviews, but since Hacktober is over, Hacktoberfest is over, so there's not that many pull requests. So we're probably going to finish all of the pull requests tomorrow, and yeah, we're still going to have 2 game development streams anyway, so don't even worry about that. Don't even worry about that. So instead of Saturday, Sunday, we're going to have Sunday, Monday. Sounds good? Sounds good? I think it sounds good. Anyways, so yeah, today we continue doing whatever we did yesterday. Check out the previous VOD, the genetic programming part 1 VOD for more information on what we're doing. I can do a little bit of a recap. So what is genetic programming? Or genetic algorithms, right? Let's talk about genetic algorithms. I feel like people use these terms interchangeably. Like, I don't think there's that much of a significant difference between them. But it's essentially optimization technique where you randomly searching for optimal solution. You represent solution as a string, which is called a chromosome, right? I didn't come up with the terminology, they just want you to call it a chromosome, right? Then each character of that string is called gene, and essentially you encode your solution as that string, right? So you generate a bunch of random strings. You have a so-called fitness function or fittest function, I don't remember how exactly it's called. You pick up the fittest chromosome, and you actually pick up several of them, right? You cross over them together by actually slicing chromosome like in half and combining them together. And you also perform random mutations, and you check the function, the cost function you're optimizing yet again, and repeat the process until you find the solution optimal enough for you. So one of the limitations is that your solution has to be encodable in string. Yeah, so that's basically genetic algorithms. It's just basically using algorithm like of natural selection to find the optimal solution for your problem. It can be actually any kind of problem. The only limitation is that your solution has to be encodable in string. Does that make any sense? So yeah. And what we came up on the previous stream is a small game where we have a bunch of agents that actually fight for survival. Right, they're searching for the food. They can actually eat each other. So, and basically their behavior is encoded in a small state machine. So, and my idea was implement that game and use some sort of a genetic algorithm to find the fittest agent that can actually survive anywhere. So that was the idea. You can find the source code of this of the project that we started yesterday here, and today we're gonna just continue doing that. So here is a recap, boys and girls. Here's a recap of the previous stream. So on the previous stream we started doing visualization. We already have a sort of like visualization. Today we're going to continue doing it, and I want to also finish the simulation so we can simulate like a game, and once we're done with that we can start trying to implement the genetic algorithm that searches for optimal solution for a particular agent. All right, recap is over. Hello everyone, hello I Good Duke, hello Hotzenplots, hello Archelesus, hello I Good Duke, Hotzenplots, Mr. Botka, Hamikovic, Ketison, Archelesus, Iceleo, I don't see anybody 28, hello Ant Rax, hello, really glad to see you all today, Funkchi, welcome, so yeah, how about that? So then actually when playing with evolutionary algorithm I found that you can just ignore fitness function and just have a fixed agent count. When one dies you pick randomly from existing ones, so good ones get to reproduce more. Leads to a lot of... Oh, I see what you're talking about. So when you're talking about Hunger Games, right, and the individuals die, they naturally basically like get filtered out. Like you don't even need to calculate the physics function. You just you just let the simulation play and you spawn more and more based on the existing. Oh my god, this is actually a pretty cool idea, Esleo. Thank you. I like that. I really like that. How do you make sure, if possible, that the string after crossover operation still represents a solution? I don't know yet. I was actually thinking about that problem, because this is the obvious like problem that you will hit into. And you know what I'm gonna do? I'm gonna ignore that problem for now. I'm just gonna implement the algorithm, and I see how the problem sort of appears when you try to execute the solution, and then the solution to that problem is going to be more obvious. I don't know for now. I'm going to just implement it. It's going to be probably broken, but then we can talk about how to improve it. So yeah. All right. All right. So let's continue. Yet another hello everyone who just joined. And let's fetch the origin. I don't think I actually did any committee. So what's the status? All right. So did we even formalize any rules anywhere? Free Fall, welcome. Chessme, Lars of Laverne, welcome everyone. Alright, so already started Emacs. Is that the right instance of Emacs? I don't think it's the right instance of Emacs. Let me restart it just in case. So right now, in the definition of the game, so let me actually find the game. So we only have 3 kinds of objects on the board. Have you heard about MXCD? Yes, I actually use it quite often. Not quite often on the stream, but yeah, basically to change the current directory of the buffer, right? So because different buffers can have the different like currently working directory, and you can change that with CD. So right now in the game, in the state of the game, we have agents, right? We have food that the agents can eat, and we have walls that the agents have to bypass or something like that. So, and we also initialize the game. By generating random agents in random positions, random directions, and food in random positions, and walls in random positions. And that's pretty much it. And we only implemented visualization of all of that stuff so far. So let me try to recompile that. In C, you have to use type def to declare a struct. You don't have to, but that's what a lot of people do. And there's a reason for that. Okay, so this is how the visualization looks like. And we have an obvious problem here, right? So sometimes the objects are generated on already taken cells, right? So we're gonna fix that a little bit later, right? So it's a separate problem, we can fix it a little bit later. Another problem is that the food is supposed to be colored green, but it's colored purple, right? And the reason is bug of GFX, SDL GFX that we're using. I don't know what kind of bug is that, but the color is supposed to be completely different. So here's supposed to be the color. Where is my Chromium? So can I see the color? Google, can you do colors? I remember even Yandex can do colors. Can it not? I think it can. But maybe because this is because I'm not logged in. So, okay, so the food is supposed to be this color, right? It's supposed to be green, but if you look at it, for some reason it's purplish. Yeah, Yandex can, because I remember a long time ago when I was using Yandex, I really liked that feature. You can just put like a hex. Oh, wait a second, I think I did a fucky-wacky. I think you have to do something like this. Yeah, there you go. So it does not recognize it as a like color hex until you have like a hash pound. That makes sense actually. Yeah. All right, that's cool. Okay. So how do we actually provide the color to the SDL GFX? render game, right? So we're rendering the food, and we're using field circle color function, right? That accepts the renderer that is used for render things. The parameters of the circle, the first two things are the center of the circle, this one is the radius, and then it accepts the uint32, the value of the color, right? So it's the color of the pixel, but apparently it just has a different format. We assume format RGBA, but it uses something else, and the documentation says that the format has to be RGBA, but it just treats it as not RGBA. So it looks like a straight up bug of the library. All right, so let's take a look at the function itself. So SDL, GFX, primitives, and here's the field circle. So let's actually find this thing. Let me also disable white space mode. So here it is. So it accepts the color. What's interesting is that there is another version called field circle RGBA. Maybe a little endian, big endian issue, probably. But I think it's not going to be relevant much, and if we come up with the right solution. There's another one where you can provide the components of the color separately, right? But it's not really convenient because we have a color in the form of U32. So that means we'll have to like first parse the components out of the U32 and then separately provide them with this function. But I actually came up with an interesting solution for that. So we have a code that parses the U32. Here's the code that parses U32. So what if we create a macro called hex color, right? That accepts obviously hex. And guess what it expands to? Guess what it expands to? It will fucking expand to that literally, right? So you see what I'm doing here? You see what I'm doing here? So, and of course here for each hex we have to wrap it in parentheses because it can be an expression, right? So, and yeah, I can remove that. So essentially, instead of doing it like that, you can just do it like that. So basically it expands to several arguments simultaneously. Even though this function accepts more arguments, we use a special macro that just expands to more arguments. Right. Let's try to compile that and see if I didn't break anything. I think I didn't. Yeah, everything is as usual. Now, let's go to the field circle. Right, let's go to the field circle. And we're going to use RGBA, I think. Is it RGBA? Yeah, it's called RGBA. So if you try to use this function, obviously it's not going to work because you have to provide more arguments. But then you can do hex color, right? Wrap it like that. And now everything is fucking colored correctly. So we're essentially using this different function, and we have a special macro that automatically parses uint32 value and spreads it across several arguments. You see? You see? Did everyone understood the trick that I just did? Because it's actually a pretty interesting trick in my opinion. I don't know if I ever saw such tricks. Such trick used before with SDL. What's cool is that like a lot of SDL functions, for some reason, yeah, and this is something that bothered me with the SDL for quite some time. SDL has SDL color type, right? And SDL color type is defined as a structure with U8, RGBA, and so on and so forth. But yet, there's a shit ton of functions like SDL set render draw color that accept these arguments separately like that, and they don't accept SDL color. And I always wondered why, right? Like, why don't you just accept like a single thing here? And I don't know if this is because you're supposed to use macros like that, or I don't know, seriously. So yeah. To be fair, if you think about it, if the color is defined like that, it essentially fits into U32, so maybe... wait a second. But some functions expect as value parameter which breaks FFI. Screw me over once. Oh shit. Yeah. Goddamn. Just to below the functional weight. It's the only struct by value I've seen in SDL. That's really weird. Here's what I found on SourceForge for SDL, GFX. What's that? Oh my god. Wrong ordering of on circle color and others. I see. So it's literally a bug, apparently. To have a web when looking. All right. So yeah, apparently it is a bug. Okay. SDL GFX is really buggy apparently. Thank you for letting me know. All right. And what's funny is that this kind of like function is so trivial. I don't think I want to actually keep the instance of this function. I might as well just, you know, remove it and call SDL set render draw color directly, because why not? I mean, alright. So also let me adjust things a little bit, because OCD slightly kills me if I don't do that. All right, let's go through the compilation errors, and yeah, here's the first thing that we have here. So it's gonna be SDL, LSD. Why did my fingers type LSD? SDL. Set render, set draw. What was that? Set draw render color. I forgot how it's named. I can never remember the naming. So implicit declaration. I already forgot this thing. Right. Okay. How was it called? Set render draw color. Like for some reason the naming in SDL makes it super difficult for me to remember. Like I can never remember the order of these words. Like it just doesn't make sense for me. All right. So in here, let's just find a macro that has the name of the GFX function to fix the bug. Yeah, sounds like an interesting idea. All right. So another one. SDL set render draw color, and I can just do hex color. Anaboth, hello, Anaboth, Hamikovi, I already, that random tanker, hello, really glad to see you all today. Really glad to see you all today, welcome. Set render draw color, and then we're gonna have hex color. And everything looks okie dokie karaoke. We fixed the problem with the color. How about that? So, and I think I'm gonna use this kind of macro like from now on. But yeah, it takes a BGR, but now we don't have to think about that. Like it just doesn't matter. It's a relevant problem. Fix coloring of the food, right? And we're gonna push that right into the repo. Genetic programming was an excuse to work on supervision UI programming. Yeah, but I need just something to visualize the process, because it's kind of difficult for me to study anything if I don't have any visualization, because I'm a very visual person. It's quite important for me to see how things work. All right. So what's the next problem we want to solve? What's the next problem? I think the next problem is going to be actually not spawning things on already taken cells, right? So init, and I think the easiest way to approach that would be very funny, cool. Thank you. So the easiest way to approach that would be to have some sort of a function is cell empty, right? And it accepts the game and also a cell, right? It's a position X and position Y. X position Y. And it simply answers whether is there something on a particular cell here, right? And we can use that to actually just generate a random point, check if something there yet. check if something is there, and maybe then generate like a next point. So how we're going to do that? I think the easiest way to do that is just to iterate through all of the agents and iterate through all of the foods and all of the walls and just check if they have the corresponding coordinates. So I'm using very dumb and very linear algorithms, right? So I don't have any fancy data structures like spatial trees or anything like that, because we don't have that many agents and foods and walls. And so the performance of the application is not the concern right now. Do the agents only see the cell they're on, or do they have any idea about surrounding? The agents have the idea of a direction. They see the objects on the next cell according to their direction, according to where they're looking at. So yeah. And they also have actions to rotate themselves. They can rotate left, can rotate right. 1 second. I think action. Yeah. Oh shit! I forgot to actually add them. Thank you for reminding me. So we have only no operation, step, eat, attack, and action turn left, right? And action turn right. Action turn right. Imagine starting using smart pointers. I used to use smart pointers a lot, actually, when I was working on a commercial C++ project. And this is because the project was using them, so that was like the style in which you're supposed to develop things. We were using shared pointers. And one of the things about shared pointers is that if you don't plan to modify a thing that you pass by a shared pointer, you better pass it by a constant reference, because you don't want to increment the inner counter because it's slow. I do remember that, yes. It's such a fucking beautiful data structure, oh my god. And also shared pointer is supposed to be like thread safe, right? And because of their thread safety, if you copy them and they increment the counter, that is additional runtime cost. Weak pointers are made for that. No, yes, they are, but the project wasn't using weak pointers. So yeah, I usually just follow the style of the project that I'm working on, right? So yeah, the project wasn't using that. Well, I mean, that means I'm not going to use them. Who am I to tell the project how to develop itself? Anyway, let's recompile. And what am I recompile? Okay, so we're going to iterate through all of the agents. We're also going to iterate through all of the foods. Oh, the fuck happened? Are we live? Just a second. Yeah, everything's okay. Okay, well, my Discord crashed for some reason. Maybe it's something with Discord, I don't know. Right, so let's continue iterating here, and this one is gonna be walls count plus I. So essentially, right, if game agents I pos x equal pos x, or their pos y equal to pos y, then we're going to return true. Right, and this is essentially what we have to repeat several times, and I think the time has come to introduce some sort of like a point or a coordinate. POSIX, yes. I think it makes sense to introduce that, because like doing this kind of stuff all the time is not a particularly great idea in my opinion. But again, you cannot just compare structures with the comparison operator. You will still have to come up with a function that compares positions and coordinates and stuff like that. Okay, so let's actually create something. So we have a board, or so I suppose I'm going to define struct, actually type def, and this is going to be x and y, and we're going to have a point here. Let's call it point. Coordinates. Yeah, it's essentially coordinate. It's essentially a coordinate, and in agent, inside of agent, we are going to have point position. For the foot, we're also going to have point position. And for the wall, we're also going to have point position. There we go. So, and I suppose I'll have to go through the compilation errors to quickly fix all of that. Unknown type point. Like, why are you saying it's unknown? Excuse me. Point. I just renamed point to coordinate and I instantly forgot that. Jesus fucking Christ. My brain is so pepega. Oh, God. Why my brain is so pepega? I don't know. Alright. So, yeah, I might as well actually do it like that then. Pose x, pose dot x. Anything else? Pose y, pose dot y. Boom. Anything else? Oh. Classic. Fucking classic. Alright, so in here, we can do something like coordinate position. And we need some sort of a function, right, that tells us with a coordinate equals. Right, I'm gonna accept coordinate A, coordinate B. AX equal BX and AY equal BY. There we go. Cool. So, and in here, I can do chord equals this position. There we go. So, and I can see that actually that this simplified everything, hopefully. False, and then we can return false. There we go. So now we have a special function that checks if there's something on a particular cell. Yep. And now we need to integrate all of that into the game initialization. Right. Into the game initialization. When we're generating a random agent, we basically have to generate a new point, check if it's empty or not, and if it's not empty, keep generating until we find the empty one. Right. Make sense? Make sense? I think it makes sense. So, and to to do that, I want to have a special separate function. Random chord on board. Random empty chord on board. Right. So, and this is where we're going to actually do all of that. So, essentially, we're going to have a chord result. Right? Chord result. And we might as well introduce random chord on board, right? So, as you can see, we have like a separation of concerns here. And this entire thing is going to be result. X is equal. Let me copy paste this thing because this thing does exactly what I want here. It does exactly what I want. There we go. And then we just return this thing. Right. So random coordinate on the board, and while is cell empty. If it's not empty, we keep generating that shit until it's empty, and then we return this thing here. So it would be nice to have some sort of like a prevention from going into the infinite loop. So we can do something like this. Times times equals 0. I mean, it's already equals 0, so we're not going to do anything here. Then we're going to have plus plus times, and then add times less than max attempts, max try attempts, right? Something like that. And let's actually do something like 100, right? And then we're going to do a very interesting thing. We're going to assert that times is less than max try attempts. There we go. So basically, if we this condition makes it so we never go into infinite loop, and this condition, this assert, makes sure that if it exceeds the amount of available max attempts, it will report to us. It will essentially crash. What if we are very unlucky? Well, that means I'm very unlucky. Okay, so old style. Yeah, okay. Jiang, thank you so much. I hit walled again. I'm not sure if Jiang is watching this right now, but yeah. So he suggested to add this thing because I already burned myself by forgetting to add void here. So yeah. So this is another one, and this is implicit declaration is cell empty. Well, it's not really implicit declaration. What the fuck? So maybe I have to is cell empty. So I'm probably gonna put it here somewhere. Alright. Incompatible type of argument. Oh, you also have to... Alright. So, yeah, we need to have a pointer to the game. Yes, we need to have a pointer to the game. And then... Yeah... To point it to the game. This is the game, and this is where we also have to pass this thing. Because without the game, they cannot really do anything here, right? And do we really care for the game here? No, we don't, actually. Alright, so random coordinate on the board. Yeah, we don't need that, excuse me. By the way, I played around with training something like GPT on searching chat logs. Oh, cool. Nice. How did it turn out? Did it turn out good? Hopefully it turned out good. Alright. So, I guess... To be fair, when we're gonna have such situation? So, okay, so somebody was talking about checking whether the board is full. It was IceLeo, yes. It was IceLeo. So the board is full, actually. If you think about that. It is full when the sum of these values is greater than board width multiplied by board height. That's right. So we need to make sure that this thing is like that. I wonder if it's gonna work like that in C. I think the modern, like C11, have a static assert, but I don't quite remember. And it also accepts like a pointer. Too many entities can't fit all of them on the board. There we go. Cool. So, and I suppose maybe because of that, we don't really need this prevention mechanism, because I mean, eventually it will happen, right? Eventually it will happen if we have like at least one thingy there. So I think it's okay. All right, cool. So now, in init game, when we're generating a random agent, we're gonna just generate random empty coordinate on the board. We're gonna provide the game, and we actually have to pass the game. Yeah, we'll have to pass the game. So, yep. So we'll have to pass it here, and. Alright, it actually generated all of them here. I think I made a logical mistake somewhere because I'm an idiot. So while it is not empty, we keep generating them. So if the coordinates it is not empty, so all of these returns have to be 0. Yeah, the logic is actually upside down. Alright, so, but that only works for the agents, it doesn't work for foods or anything like that, so it's gonna be a init game. Then for the foods, we're gonna do the same shit. Mahith Varma, thank you so much for 25 bits, thank you, thank you, thank you. And welcome to our epic genetic programming stream, how about that? Random empty coordinate on board. And yeah, we're gonna do it like that, and for the wall it's gonna go the same, right? So random empty coordinate on the board, game. There we go. And as you can see, everything looking good. Everything looking good. So they're not generated. To be fair, we're not initializing the seed, right? We're not initializing the seed at all, and maybe this is something that we need to do. Yeah, so something like srand and use time 0 to initialize all of that. So let's see how it's gonna go. And every time I run this thing, it's gonna be different. You see different combinations, and every time we initialize the game, of course, the entities don't spawn in the same cells because we check for all of that. All right. So yeah, I think it's pretty good. I think it's pretty good. So I think I need to also include time, because I'm using like implicitly declared function, which is not good according to the, it's not times, according to the compiler. According to the compiler. Alright, seems good, seems good. Let's do a committee chat. Don't generate entities on the same cells, right? And I'm going to push that right into the repo. And just a reminder that all the source code that we're developing here is available on GitHub in its organization. You can check it out. All right. So let me see. So can I actually, you know, by pressing like space, thank you Mahith Varma for another 25 bits. Really appreciate that. Also, the C RNG is probably not the best for simulation. You need your RNG. Yeah, it's actually a pretty good point, but the problem is we don't have anything implemented yet. And if we're gonna start picking up on such small things like not the right RNG, we're not gonna implement anything. Let's implement something with a bad RNG, and once we have something, it's actually super easy to replace RNG. Don't you think? Right. So because thinking about these kind of like small things, it actually stops, it actually blocks the whole problem. I think we should just forget and implement with as many problems as possible. And then we can, you know, work on this problem separately. Like we need to have something working. We need to have something like moving, farting, blinking, flashing or something. You see my point? Because then it will be easier to fix those problems. It's kind of difficult to fix those problems when you don't have something working. Cheers, by the way. So so why are agents not using random and instead using a random agent one? Because random agent, to generate a random agent, you also have to generate a random direction and initialize hunger and health and stuff like that. Does it make sense? But I mean, I can just inline this function for the consistency. Why not? We can just go ahead and inline it. Because, yeah, it's such a small function, it's not used anywhere else. Maybe it does make sense to just, you know, fucking inline it. I actually wanted to inline it for quite some time, so let's quickly do that. Yep. So, and now random agent. This function is obsolete and is not needed anymore. There we go. Inline random agent function. Yeah, we can call it like that. Because I'm not sure if it if this function is that reusable, so I have to extract it to a separate function because I might as well just keep it like that. Like, who cares? So interestingly enough, I can assign some sort of a key, right? I can assign some sort of a key. And every time I press that key, I can reinitialize the game. Right. Yeah, I can just look at different combinations of the game. We can try to increase the amount of agents. Like, we can have like 10 of these things. And I wonder what's gonna happen. Okay, so this entire thing will fit, hopefully. Okay, yeah. So we can more different combinations. So what if we have like a very small board, like, so we have 30 entities, but what if the board was 5 by 5? That means you can only have 25. So this will not compile. So this assert actually prevents us from the situation when you don't have enough space for the entities. So that's why compile time checks are so goddamn important. Makes sense? Makes sense? I think it does make sense. So what about actually like 20 by 20? 20 by 20, and you have like 20 of each of the entities. So you can have this kind of stuff. Oh, and I don't really like the fixed padding. Look at that. They have a fixed padding here. God damn. Doesn't really make it look good. So maybe we can quickly fix that. So fixed padding might actually depend on width and height of the board. So we can do something like minimum. I can't look at the name of this function anymore since what happened in the last stream. So yeah, I'll have to take a board width. Here's a board width and board height. Because for those who doesn't know, I tried to Google fminf, but I accidentally forgot to put n. So try to Google fminf, but remove n, and I didn't know that. Like, I mean, that was fun. Yeah. So essentially, what we can do, we can just take that and divide that by 3. So this is going to be agent padding, and the agent padding, oh, and the foot padding is the same as the agent padding. There we go. Oh, there we go. So now, regardless of the scale, they sort of pad it appropriately. Yeah, it looks okay. I really like how it looks like. We can increase it, like 30 by 30. Wait, I cannot believe that. The padding still looks like shit. It's not supposed to look like that. What am I missing here? So board width, you take 30 and divide it by 3. Okay. You need to take cell... Okay, I'm an idiot. It has to be cell width. There we go. Oh my god. Cell width and cell height. Out9, hello, welcome to the stream. Don't be sorry for being late. I mean, come on. Hello, welcome. You didn't have to be sorry. Welcome. So, yeah, I don't really like the padding here. And by the way, hello everyone who just joined recently. Wouldn't that fminf be called every time agent padding is referred? Yes, I think it will. But there's nothing I can do about that, I think. In C at least. In C++, I think such things can be pre-calculated at compile time. But I think with enough optimizations, C compiler can figure out that you can pre-compute fmin. So let me demonstrate you. Got bolts. Let's actually check it out. So imagine that you have this kind of stuff. I'm gonna straight up copy paste this entire section into Godbolt. So we're gonna switch to the C. It can with built-ins. Yeah, I think so. Now, if I do something like float f, and I'm gonna return, what was that? Foot padding, right? 03, And if we take a look, there you go. It actually, I think it literally precomputes. So the whole function is just returning a value out of the register, I suppose. But it doesn't make any sense. So it moves it. Okay, so it moves it there, and then yeah. So I think it actually precomputes everything. Yeah. So I don't think it's that big of a problem. I don't think it's that big of a problem. I have a simple math library I copy to project so compiler can inline everything without dynamic LM. Oh, you sound pretty cool. Nice. All right, so I don't really like 3. Let's actually make like 4. So what if we have 4 as a padding? It looks a little better. What about 5? Yeah, it now looks even better. So, and here are different combinations of this stuff. So if we have like a smaller thing, let's go back to 10 by 10. And it's a little bit like cramped, but they still fit. Yeah, racket. A racket. A racket. Okay. What did I do in this commit? I actually did nothing. I just introduced like a key binding and I experimented with different generations and stuff like that, so I don't think it's that important. So I think the time has come to try to simulate the game, right? Because that's exactly what we're trying to do here. We're trying to implement this simulator that will simulate the game. Yeah. So the agents should have a brain. Do they have it? They actually don't. Huh. They actually don't. I'm thinking, should they have a brain associated with the structure? I actually don't know. But I have an interesting idea. By the way, Sodium Pledge, no network stuff, your advanced AI can't escape to the internet. Oh, yeah, I'll definitely do that, so don't worry about it. I'll definitely do that. So, by the way, so as already mentioned at the beginning, so usually, classically, the genetic algorithms are implemented by encoding your solution into a string. Right, so, and that string is called a chromosome, and each individual character is called a gene. So what's interesting here is that in case of this kind of like Turing state machine, each individual row of the table can be considered a gene, and the whole table can be considered a chromosome. Right. So, and maybe we don't even have to encode anything. Maybe we can work directly on mutating and cross-overing the brain cells themselves. So in our case, brain is a chromosome and brain cell is a gene. And maybe this is exactly what I need to call them. My advanced AI is so advanced that it can even compute a sort properly. Yeah, so I remember that feeling, like with my own neural network in Haskell. It kind of does, but it's so Pepega as well. So yeah. But I kind of like a brain cell and brain, but maybe gene and chromosome would be a little bit better. Chromosome. And at the same time, maybe we're gonna actually have a fixed amount of genes in a chromosome. So it's gonna be like genes. So, and we're gonna have genes count. Matthewsef777, welcome to the stream. Welcome. Size underscore T is defined in the standard library. Yes, it is defined in the standard library. And we're gonna similarly have this thing here, genes count, and let's say that we're gonna have 20 of them. So basically you have like 20 slots in your in your chromosome, right? And then if we're gonna cross over them, crossbreed them, we can just divide it by half and just give the halves to different. So we can take two agents, split their chromosome in half, and then combine them together to get a new agent, a better one. And then mutating a single gene would be actually pretty easy, I think. These species are very millennial already. They were nothing but genes. Thank you, the thinner. Excuse me. Now. Chromosome. Let's call it chromo because I don't really like how long chromosome is. So let's just call it chromo. And this is chromo. Chromos. Sodium don't use genes, they're too slow. Use machines to compute thing. You can. Sorry. I'll use the machines. All right. And how we're gonna? Yeah. So it's actually agents count, right? So because we have each chromosome associated with the agent, and I kind of want to separate them. Right, because this is the state. Oh shit, wait a second.
14 months. Now let them sing my monthly singing.
Thank you. Thank you, Shazavak, for 14 months of Twitch Prime subscription. Thank you, and welcome to our epigenetic programming club. You know, it's epigenetics stands for epic genetic programming. Yeah, that's what epigenetics stands for. All right. OMG, play that again. It's so good. You know what? You can actually subscribe yourself. And you can put any message there, and you can just copy-paste the Shazavak message and listen to it. How about that? Cool idea, isn't it? All right. So, so agents are just the state, right? Agents are just the state, and the chromosomes are, you know, the actual behavior that doesn't really change that much. Yeah. So then we have genes and I kind of want to call it genes count still. Genes. Genes count. God damn it! Query replace genes count. Genes count. There we go. Now we need to come up with a code that interprets the chromosomes. Right, it interprets the chromosomes and just. Interestingly enough, we do not generate the state, so the initial state of the agents is going to be 0. Right, the initial state of the agent is going to be 0. And maybe, yeah, maybe that's gonna be like a baseline for that. All right. Step the game. Right. Step the game. So for each individual agent, we to step the game, we just need to iterate through all of the agents and step a single agent. So agents count, right? Agents count. So game agents I. So let's actually call it step agent. I think it's going to be a little bit easier to work with. To be fair, to step an agent, you still need to have yeah, you still need to have everything. All right, so agents, we're going to take the state of the agent, right? So here's the state of the agent. Why did I look at the chat? Jesus fucking Christ. Okay, so now I also need to iterate through all of the chromosomes. Through all of the genes of the chromosome of the yeah, of the agent. So it's gonna be J. So how do we have genes count, right? So here we are iterating through each individual agent, right? And for each individual agent, we iterating through each individual gene of that agent, right? And we do that to actually figure out what we have to do in a particular state of the agent in a particular environment. Because the state machine here, like a single gene, right, a single gene can consist of like 4 things, right? It's the current state of the agent, what the agent sees on the next cell in front of it, what action it needs to perform in that case, and what state it have to switch after performing that agent. What I was talking about, and so essentially we iterating through each individual gene of the agent, right? And we find the corresponding state of the agent, and we just look up what needs to be done in that particular state in that particular environment. Make sense? I think it makes sense. Okay. I do think it makes sense. Step a game. So so it's gonna be game chromos I. So we take in the chromosomes of the ith agent, not engine, agent. And then we take a look at the genes. Yeah, thank you so much. Yeah, so jth gene of ith chromosome. Jesus fucking Christ. Thank you so much, Isleo, for 100 bits. Thank you so much for supporting our epigenetic programming club. So yeah, so in the genes, we also have a state, right? And if that state corresponds to the current state of the agent, that means we probably found the right gene, right? We probably found the right gene. What's funny is that what we're implementing right now, we're implementing like a Turing machine interpreter, because there is like isomorphism between Turing machine and the, well, the reason why there is isomorphism is because Turing machine is literally a state machine, right? It's a state machine for a head that moves on the tape, right? But here we have an agent moving on a 2-dimensional plane, and it's kind of similar to that. Right, and we already implemented the Turing machine in one of the previous streams, so I think you can find the VOD on that in our YouTube VOD channel, right? So we actually did that. We did that in D. So we're kind of doing the same thing right now, but in C and for a 2-dimensional game, right? So each individual agent is like a small Turing machine. Each individual agent is a small Turing machine. Step game. All right, so we found this thing. Now we need to figure out what's the environment of the agent. So we need some sort of a function. Env of agent, right? And we can get the game. And I think we need to accept the index of an agent. Agent index. There we go. Are his votes a subscriber only? It's actually not a bad idea. Wait a second. Okay, so here's an idea. So I'm gonna make my VODs on Twitch subscriber only, and I'm gonna upload VODs on YouTube for free on the next day. Stonks. I'm not gonna do that, I'm joking, but yeah. If I ever will need money, I might consider that an option. Because that's actually a pretty cool idea, because it's like I'm not limiting you to watch, but if you want to watch it as soon as possible, you can pay a little bit, but if you don't want to pay, you can just wait 24 hours. I mean, I think it's a pretty good model. So, I'm not going to do it for now. Like, I'm going to just keep it at the back of my head, like a plan B if I really need money. You're joking, but a lot of... Oh, so I'm not the first one who came up with that idea. Alright, so I mean, it's kind of an obvious idea, so I don't know. But yeah, at some point I may consider it. Alright, so we need a function that takes an index of an agent and tells us what the agent is currently seeing. Right, so we have a special type. Right, so that describes what the agent can actually see. I will just ask Archelaus for a free sub. No, I'm too nice to do that, I'm sorry. What if I die the next day? That means you die the next day. I mean, if you die, you die. There's nothing I can do about that. I still haven't learned how to revive people, I'm sorry. But I'm working on it, don't worry about it. So...
Just upload them to OnlyFans.
Sure, I'm gonna start uploading to OnlyFans, don't worry about it. By the way, what's the longest video you can upload to OnlyFans? I don't really know. Okay, so we have this thing that describes the environment and shit like that. And let's implement this thing. So, this one's gonna be very interesting. So what if the agent looking... Do we want to wrap around our board? I think we do. I think we do want to wrap around. Does anyone have a summary of the goal of the genetic programming? Optimization. Right. The goal of genetic programming is optimization. So you have a solution that you want to optimize. And if your solution is encodable into a string, then you can use genetic programming algorithm or genetic algorithm to randomly, like stochastically search for a good solution. So that's pretty much what it is. There's nothing magical about it. It's just, you know, randomized search, essentially, inspired by nature. Yeah. To be fair, this kind of approach could have been literally called stochastic search for optimal solution, but in that case, the creators of this approach wouldn't get any fucking grants, because that sounds boring, that doesn't sound innovative, right? But think about a genetic programming inspired by natural selection. My god, I want to throw money at that shit. So yeah. Anyway, the same with artificial intelligence, by the way. So we need like a separate kind of functions, I think. We need functions that check whether you see food. Does agent see food? Yeah, we can do it like that. To be fair, we can just align that. Clickbait programming. I would say it's more of a clickbait research, right? What's interesting is that a lot of researchers have to play the same clickbait game, but with their papers. Otherwise, they just don't get any fucking money. Yeah, blockchain also has the same thing going for it. That's for sure. Hey, I got here to intellectual masturbate. Can you help? Well, you know, relax and enjoy the stream, I suppose, because that's exactly what we're doing today. Anyway, so I want to iterate through all of the foods and game foods count. There we go. Foods count. Excuse me. If, and we need to actually come up with the point at which the agent is looking, right? So we need something like chord in front of agent, right? Chord in front of agent, and essentially, do we need to take the index of the agent, or do we need to take the agent themselves? I might as well. Yeah, I think the agent itself would be okay. So it's going to be agent. Yep. And we need to take the position of the agent, then the direction of the agent, combine them somehow and get the coordinate in front of it. Right. So how can we do that? I think we should come up with the table, right? We should come up with the table. Chord dirs, and we're gonna have like 4 of them. And if I remember correctly, this kind of thing is gonna be similar to the triangular meshes that we created somewhere up above. Yeah, agent dirs. Right. And this one chord dirs. And essentially, so we have right, up, left, and down. So we'll have to come up with the directions here. So does it necessarily have to be chord? I think so. I think it has to be chord. So let's do query replace. Let's remove that. Scheiße. Then turn it into the comments. I didn't put space. It triggers my OCD. The fuck? Hate it. All right. Right. To go to the right, you need to just increment 1. X. There we go. Up is going to be 0. Minus 1. Left, minus 1, 0. Down, 1. There we go. We have all of the possible directions. Chord dirs. Step game. Chord dirs. Then. Hello, Thresh5. Welcome to the stream. Very glad to see you. Agents. Agent index. Then we take the direction of the agent, right? So we get the direction, and we can call it a delta. Right. Call it a delta, and then we can come up with the result. With some sort of result where this thing could be initially equal to this thing, like position of the agent, but I'm not sure if you can initialize things like that. I'm gonna try it. So it's gonna be x plus dx and y, and there we go. We have, yeah, I'm actually doing that in the wrong function. God damn it! And then I can return the results. So and nothing. So yeah. Is not implemented. And to do. There we go. All right. So is it gonna compile? Oh yeah, I'm an idiot. I'm sorry. So this entire thing can be replaced with just agent. And an arrow. Shit! It compiles. Oh my god! And if it compiles. Chat, say the line, chat. It works. But to be fair, I wanted this entire thing to wrap around, right? I wanted the entire thing to wrap around. So that means we're gonna do it like this. Result x plus. It's actually, this one has to be y. And we need to have something like mod. Right, and the mod is going to be board width What language is using? We're using a programming language. Okay, cool. All right, so let's implement. Actually, this one is mod int, right? Because it's an int situation. Mod int. So we have a and have b. A, b plus a plus b, and mod b yet again. There we go. Should be okay. Should be okay. All right. So then we take a coordinate in front, chord in front of the agent. It's a game agents. So all right. So we need to find what's in front of the agent. To find out what's in front of the agent, we take the coordinate in front of the agent. So we know that the whole world can wrap around, right? The whole world can wrap around. What we're doing, we iterated through all of the foods. If game foods I position chord equals to the coordinate of in front of the agent position, that means we can instantly return environment food, right? So there you go. We just found it. We just found it. Next thing is going to be essentially walls. Nothing special. So what's interesting is that if the agents are on the same cell, they won't be able to see each other. And maybe that could be a part of the game. I have not decided yet, but that's just the fact. Right, it's just the fact. So we have walls, and similarly, we can have agents. So a wall. I think I can use like this thing. Query replace wall agent. And I'm gonna replace this scheisse. And that's it. Okay, so this is how we get the environment. Basically the object in front of the agent. I think it makes sense. All right, so if the state of the agent, of the currently iterating agent, matches the state of its corresponding gene, the next thing we have to check if the environment of that gene corresponds to the object in front of the agent. Right, something like that. The object in front of the agent, so game I. And if it does, we literally found the right gene to perform. That's what we did. We found the right gene to perform. May I see the coordinate dir parts again? Sure. Here it is. And this is the place where we use it. You're welcome. All right, so maybe it makes sense to actually take this thing and put it like that. I'm not sure if it makes it that much readable, but I think it makes a little bit more sense. To be fair, we could have just, you know, extracted the gene like this. Right, so here's the gene, the current gene. Yep. Yeah. So here's the current gene, and if we found one, we have to perform an action. Perform action. So what's going to be the action? So we have to provide the game, we have to provide the index of the agent, and we have to provide the action. So the action is in the gene. You see, so this is basically what gene encodes. And it codes what the state the agent has to be in, what the agent has to see in front of it, and then what action it has to perform. And after we perform that action, we have to take our agent, and switch it to the next state according to the gene. To the next state according to the gene. Next state. You see, this is the whole interpretation of the chromosome of this thing. Image is still using semicolon to separate function argument. I'm out of the context, but yeah. Semicolons. Oh, all right. So it's kind of cool because this is pretty much the Turing machine interpreter. This is pretty much Turing machine interpreter. So, oh, you mean commas? Yeah, I see. Yeah, I can imagine because I do that all the time. Unless I program in Lisp or Haskell. All right. So, what do we have here? So this one has to be agent index. So what else do we have here? Perform action, and we don't have a function that performs an action. Right, we don't have that action function yet. So let's implement it. But how do you decide if the agent halts? Halting is actually the emergent property of this code. Can you see it, by the way? Can you see it? Essentially, it halts when it goes into the state for which we don't have a gene, or a combination of state and environment. Well, in that case, I suppose that agent is not going to survive. Maybe. We'll see. I don't know how exactly it will behave. As I already said, we need to implement the thing first, and then we'll see how it behaves. All right, so let's do perform action. So we have to accept the game. Then we're going to accept agent index. And then we're going to accept the action. And depending on the action, right, we're going to do different things. So let me find the definition of action. So here is the definition of action. Perform action. Maybe you should call it execute action. I'm not sure. I don't really speak English that well to know how we call that. Execute action. So, and yeah, let's replace this thing and remove that. Maybe I should have actually replaced this thing with colons. Right, we're gonna replace it with colons, and this one is gonna be case, and maybe after the case, we're gonna do a break. All right. What do we do in case of a NOP? Right, what do we do in case of a NOP? Nothing, because it's a no operation. What do we do in case of a step? In case of a step, we just step unless there is a wall in front of the agent. If there is a wall in front of the agent, the step will act like NOP. It won't produce anything. So yeah. So to do that, what we're gonna do? So coordinate in front of the agent. So we need to take the coordinate in front of the agent. So it's going to become agents, agent index, coordinate in front, and to be fair, wait a second. I don't think we need the coordinate from environment. What's this function called? The function that gets the thing in front of the environment of agent. Okay, so we take environment of agent. Yeah. Okay, so game agent index, and if the environment of agent not equal environment wall, we're gonna try to step. Right, we're gonna try to step. How are we going to try to step? We need chord direction. So this is going to be direction chord D of the game agent index dir, right? So you get the direction, and then we can take this thing, position X, and essentially add this thing back. Maybe it would be better to have like a separate function for that, because I think it will get a little bit convoluted after some time. So it's going to be step agent, right, and game agent index. I'm going to put it like that. So this is what we're going to have. And then we're going to have step agent. God damn it, like actually, I'm just thinking about what chat said last time. Yeah, step agent. God fucking damn it. Alright. Yeah. So agent, and then like this. It's gonna be mod agent X, and by the way, mod int. Yeah, mod int. Step game, step agent. Yeah. Very funny, very funny. So this is X, and what we're wrapping around, the board width, and here we're gonna have a similar situation for each axis, and this is gonna be height, and I guess that's pretty much it. So you see, if we need to perform an action, nope, we do nothing. If we need to step, we look at the environment of the agent. If it's not a wall, we step the agent. Okay. So the next thing we have to do, environment of agent. So if the agent has to eat, right? If the agent has to eat, we take a look at the environment, and if it's equal to environment food, first we have to kill the corresponding food. I'm really interested in your opinion about Arch. What do you think about it? Why you prefer Debian over it? I mean, I use it right now. I'm sorry, I don't know what you're talking about. So yeah. I'm literally using Arch right now. So what do you think I think about it? So this one is very interesting because I need to take the coordinate of the entity here. Environment of the agent. So, and then I also have to kill the food as well. And also increase the hunger. And the same thing is gonna probably go for here. So environment of agent, game agent index equal environment agent, right? If you see another agent in front of you, that means you have to do something here. Attack action is not implemented. Eat action is not implemented. There we go. So we have attack and eat. Because I have no idea how to implement it right now. I do know how to implement it right now, but we just don't have like a set of the right functions to do that. Because I can just check what kind of entity in front of me, right? But I cannot take that entity. Maybe we should have functions that basically return a pointer to the food in front of the agent, or the pointer to the agent in front of the agent. Yeah, I think it's going to be a pretty good idea. So turn left. Okay, let me take a look at my directions. So what are the direction? Dir. So we have right, up, left, down. So turning left is essentially increasing, so counterclockwise, and turning right is essentially decreasing. So I actually can try to do that mathematically. So I can take the dir +1 and mod around it. That could be a pretty cool idea. So turn left. So if turn left, it's just add. All right. So let me try to do that. So it's gonna be game agents, agent index, right? Agent index. Just a second. Direction. Then I have to do something like mod int direction +1 4. So yeah, essentially it will just turn left and then wrap around. The same thing will go for this one. There we go. So we implemented turn left and turn right. Let me actually go to the compilation errors. Chord deers, I think. Yeah, there we go. Cool. So now we need to implement these things. I think to implement these kind of actions, we need auxiliary functions. The first one is going to be food in front of agent. Right, what you provide is a game and the agent index, and it will return you the pointer to the food. Then you can modify it if you want and stuff like that, but if it cannot find any food there, you will get the null pointer. Yeah, I think it's a pretty good idea. So the next thing is going to be food in front of agent is not implemented. Okay, so I want to have like a similar thing here where we're going to have wall in front of agent. Food wall. Okay, wall in front of agent is not implemented. Okay, so I think I can do. I can re-implement that in a slightly better manner. Food in front of agent. I provide the game and agent index, and only if this entire thing is not equal to null, only then we can try to eat the food. So I don't remember. Food has eaten. So essentially, I take the food and I mark it as eaten. There we go. It is marked as eaten. And then we have to increase the hunger. Yeah, but we're going to call the hunger. So this is going to be agent. Game agents. Zhiyang! Welcome to the stream. Welcome. How are you fucking doing? We're actually implementing the interpretation of the genes of the agents. Right. So, and the genes of the agents are essentially like small Turing machines. So right now we're just implementing how they're going to behave in the environment and stuff like that. So yeah. So right now we're executing an action of a single agent. So we already implemented nope, step, it. We're implementing it. Turn left, turn right. We just need to implement it and attack. The ones that are actually perform like significant side effects in the environment. So yeah, they're kind of difficult. All right, so in that case, this is agent index. So didn't fit. Yeah. So now hunger, we're gonna increase it, but can we increase it? How much we can increase it actually? I don't know. If okay, so we're gonna add it like that. Food, hunger, recovery. Then if this thing greater than hunger max, we'll have to sort of set this entire thing back to hunger max because there's no min max functions there. Right, so, and we'll have to define all of these variables here. Well, yeah, but what's the opposite of hunger? When you eat, you should decrease the hunger. Yeah. So what's the opposite of hunger? Does anybody know? Fullness? Sat? What is sat? Saturation, I mean? Or is that like literally a word? I don't know. It's German. Capacity. Ah, I see. Wait a fucking second. Alright, so let's actually use German there yet. I think... All right, I'm gonna keep it hunger. Doesn't matter. All right, so agent in front of. Oh, actually, we don't need wall in front of agent. Here we need agent in front of agent. So I'm gonna replace wall with agent. I don't know why I decided to have like a wall, but I can have a wall. Why not? I can definitely have a wall. Agent in front of agent. Yeah, very, very funny. Agent in front of agent. So we have agent index. All right. So and if agent that we found in front of agent. So let's actually call it other agent. Other agent. So this is other agent. If this thing is not equal to null, we have to try to attack that agent. Obviously, agents with like a smaller index have a priority in this situation. But maybe, yeah, they do have a priority. Unfortunately, there's nothing I can do about that. We can try to like schedule those actions and just perform them immediately, but oh, you know what, we're gonna actually declare deaths after we executed all the actions. So essentially we iterated through all of the agents, we performed all of the attacks, their health can go negative, so we're gonna allow that. And then after doing all of that, we're gonna just check the healths of the agents, and the ones with the negative one are gonna be declared dead on the next step. Right. So that's gonna be the idea. So other agents. So we're gonna take their health. Is it called health? And then we're gonna do attack damage. There we go. So we're gonna have attack damage. We're not gonna check deaths right now, and I think we implemented everything so far. So we step in the game, we're performing all of the actions, and then we need to perform an action, remove dead agents, right? So this is another like action that we'll have to perform here. All right, seems good so far. I have a feeling that we'll need this kind of thing in the future. Food. A label can only be placed. Did I do a fucky-wacky? Because I don't see a label situation anywhere. Oh shit, it's one of those situations where it doesn't tell me anything properly. Okay, so this one has to be like one. Does anybody see what it's trying to tell me? Because I don't understand. A label cannot be placed in part and declaration. I'm not placing any label. What the fuck is going on? I hate when that happens. Because it just doesn't tell me what exactly I have to fix. Like, there's no label here. This is not a label. So what if I remove this thing? Okay. Food undeclared. Okay. If I declare it back. So you haven't defined the macro. Macro? You declare the variable in the case of a body. In the case of body, in the case of body. So you think I need to add parentheses, okay. So it doesn't work in C. Do I understand that correctly? So in C it just doesn't work. Alright. Alright, okay, thank you so much. Thank you. So yeah, I wasn't sure what exactly is going on there. Food hunger recovery. So we have a max hunger like 100. And recovery is gonna be, I don't know, let's say 10, why not? See, super propega, yeah, I see. Hunger max. Oh shit. Right. So, and the max is gonna be 100. As a matter of fact, when we're initializing the game, right? So we're initializing like this. We're gonna have like a hunger max. And this is going to be health max. Yeah, there we go. This is going to be health max, and let's go ahead and define this thing. So yeah, health max is gonna be also 100. So agent, yeah, similar situation, I suppose. I don't know why I thought it's gonna work. I think it works perfectly in C++, but I wasn't 100% sure. So other agent is a pointer, yeah, makes sense. And attack damage is gonna be. Let's actually keep it all like fairly simple, because we can improve that later anyway. So remove that agents. So it should be pretty straightforward. After we performed all of the actions of all of the agents, we're gonna go through all of the agents, and for each individual agent, we're gonna check their health, and if it's less or equal than 0, we're gonna declare them dead. Wait a second. There's no declaration of dead. If your health goes down 0, so the function that gets the agent in front of us, yeah, we also need to detect the moment of when they drop the food. I have an idea. Let's actually not make the agents drop the food when they die. Make agents drop the food when they die, because I don't really want to work on that right now, at least. So because that will make it super easy for me to implement, because this is the whole implementation. Believe it or not, this is the whole implementation. Yep. Also, so interpret genes. The next thing is gonna be, we have to decrease the hunger, right? We have to decrease the hunger. How the ancient will drop food if it dies from starvation? Why not? I think that could be like a feasible strategy for other agents, just to wait until other agents die instead of trying to kill them until they drop food. Why not? Interpret genes. Handle hunger. Right. So we're gonna iterate. We might as well actually do it right here. I don't know. Okay, so it would be better to keep it as a separate step. Let's keep it as a separate step. So this one is agents count, like that. And for each individual agent, agents I, hunger, we're gonna decrease it. Step, hunger, damage. Is that a good name for this variable? I don't know. Alright, and if this thing, if hunger is less or equal than 0, well, we're gonna declare the health of the agent equal to 0. So maybe they will start getting a damage or something. Why not? So yeah. Hunger. It's getting actually kind of complicated, so I'm gonna actually make it 0. Alright, so basically they're gonna instantly die. If their hunger goes below 0 or equals 0, they instantly die. Do we need to handle anything else? So we interpreted everything. Yeah, I think everything is good. So let's continue. Step hunger damage. So every step you're gonna lose. How much hunger? Hunger recovery. So maybe you can recover more than you actually lose. So it's gonna be 5. Insta death. Yeah, you have to be careful with this kind of shit. Okay, so so I think I want to also decrease the amount of these things. Let's actually make them a little bit smaller. Yep. Moles count. Yeah. So we also have a couple of asserts to do food that is not prepared. Yeah, so we need a food in front of the agent. essentially, the foot is in front of the agent. Environment of the agent. So we have to iterate, yeah, for all of the foots, less than foots count, right? Less than foots count. We're almost there. I just need to implement this function. I need to implement a function that takes the foot in front of the agent and returns the pointer to the foot, and also the agent in front of the agent and returns the pointer to that. It would be actually kind of cool to have a similar thing for walls, and then I would be able to re-implement this ugly function in terms of these three functions. I think it will be actually pretty cool. All right. So yeah, if game agents agent index, actually agent index position chord, actually it has to be in front. Yeah, so we have to get this in front thingy, right? We have to get this in front thingy. Then if the coordinate equals to the position of the food we're currently exploring, that means what we have to return. We have to return the pointer to that specific food. There we go. And if we couldn't find anything, we just, you know, we just return null, indicating that nothing could be found. Sorry. Boo-hoo. All right, so I think I can implement the rest of this thing by copy pasting this entire shit. So instead of like food, this is going to be agent. But here's the catch. In case of agent, you have to be careful that I is not equal to yourself, which is never going to happen. Yeah, you're right. Thank you. Yeah, thank you so much. Somebody actually follows what I'm doing. Thank you so much, Ian. Thank you. All right. So, do we really have to care whether I is equal to agent index? Do we really have to care about that? Because the agent is never going to be in front of itself unless we have a board one by one, because the board is wrapped around. Yeah, the board is wrapped around, and if it's one by one, you can actually see yourself. like a portal style, you know? So I think it makes sense to actually add that check, just in case. So, I not equal agent index. Yeah, there we go. Cool. For the wall. All right, so this thing has to be a wall. Agent. Actually, query replace agent wall. Right. Wall in front of wall. Okay. Wall in front of agent, and this is agent index. Okay. A little bit of copy paste. I do realize that it's bad, but at the same time, it's good. Is it not? Agent wall. Food wall. Boom. But you wouldn't be able to compile it if you have an assert for board size. No. It's actually assert equals. So the amount of... Let's take a look at the static assert. Right. If the agent is equal to 1, this is equal to 0, and this is equal to 0, and this is 1 by 1, it will actually compile. So yeah. Yeah, we use static assert in C. We're using C11. I think static assert is available in C11, is it not? I think it is. C11 static assert. There we go. In C11 is static assert. I'm not sure. I think it's... Syntax. The keyword is also available as convenient macro. So they just created a macro for that. So yeah, I guess it's a thing. And it says it's C. So yeah, it's pretty nice. I do agree, it's pretty nice. Alright. Now I can finally check compile temp stuff. Feels good, man. So should have called it walls. Alright, cool. So now I kind of want to re-implement this function in terms of the other function that I just implemented. Right, so we have food in front of the agent in front of the agent, blah blah blah. And so this is essentially what we can do. If food in front of agent, game agent index equal not equal null, I'm gonna return env food. So, and I don't have to do this thing anymore. So you see, it actually simplifies everything. So next, if I have a wall in front of this thing, I'm gonna return wall. And if I have an agent in front of this thing, so just the sequence like sequentially checks all of these things. Agent, yeah, otherwise it returns nothing. You know, in a like a C style, I could have just removed that, but I don't know. Finally, no longer doing things Pepega like deeping classes in switch statement. Yeah, classical Java. All right, all of that even compiles. I'm actually kind of surprised. We can try to interpret all of that, and to interpret all of that, I think we also need to generate random genes, because right now we do not generate anything. If we got to change one of the in-walls to agent, oh shit! Yeah, thank you. Yeah, thank you so much. Thank you. Cool. All right. So when I'm pressing step, we're actually trying to step something. But yeah, we need to start generating stuff. So what did we implement here? I think we implement here step game. Yeah, I think this is literally what we did. We implemented step game. Implement step game. I'm gonna push that right into the repo. We're pushing that right into the repo. Now, so I already call step game when I press space. So you see, it already steps the game, but it doesn't really do anything. So I press space, it doesn't do anything. Well, I mean, I just pressed R to regenerate it, but yeah, it doesn't do anything. And this is because all the genes, I presume, are filled with 0. Are they not? Are they not? So I think they are. So when we initialize in the game, init game, we also need to go through all of the genes and initialize them as well. So how are we gonna do that? So game chromo, and yeah, so we have to iterate size j0, actually 0. Genes count, right? So this is how many genes we have. So this is a chromos I. Then we have genes, J, and for each individual gene, we have to generate like a random thing. We have to generate a random thing. So where is the gene? So this is what we need to generate. Yeah. This is what we need to generate. Ah, shite. Super quick. Yeah, game chromos I genes J. There we go. So state. So how many states do we have? I think it makes sense to assume that we're gonna have as many states as the genes themselves, right? as many states as we have genes themselves. So that means I need to generate a random int range, random int range from 0 to genes count. There we go. So environment. We can implement a function called random environment, and then we can generate a function random action. Implement a function random action, and then we can implement. We can do the same thing. So that essentially generates a random chromosome for a particular agent, right? Random chromosome for a particular agent. So does the compile? No, it doesn't, because we don't have a random environment. Let's implement that. So random environment. So it's going to return this thing, random environment. Of course, it has to be this kind of thing. So for the environment, we also need to know like how many different environments do we have. So maybe we're going to introduce something like count, but that will mean that we'll have to handle all of that. And I don't really like how you just cannot take the amount of elements in the enumeration in C. It kind of drives me nuts. So maybe I just have to do that. So I'm going to introduce this trick where we have environment count, and then I'm going to introduce a trick where we have action count, and yeah, I'm going to try to recompile all of that. So, and essentially what I can do now is return random int range from 0 to env count, and similarly, if I want to return an action, a random action, I can do things like that. So instead of environment, it's going to be this kind of thing. So is it going to compile? Okay, so it complains a little bit about the actions, but I think it's not that big of a deal. So case action count. So I want to kind of assert here, saying that this thing is unreachable. Right. So this should never happen, literally. This should never happen. Okay, and I think we're generating now random genes. And I wonder if they will do anything when I press the space. Okay, so we have a random state of the game. We have random agents. We have random genes. I'm pressing the space and it does nothing. It literally did nothing, unfortunately. I don't know why, but yeah, it's kind of sad. So also, I think I forgot a very important thing. So for the foot in front of the agent, let's take a look at the implementation of this thing. So the foot should not be eaten. Foot, stream lagged a little bit. Oh, I'm sorry. Yeah, we dropped a couple of frames. I'm really sorry. I'm sorry for disappointing you, Jiang. So let's take a look. So game foods eaten. So first of all, food should not be eaten. I just realized that I forgot this thing. Also, agent should not be dead. So game agents health should be greater than 0. So this is another quite important thing here. So the agent shouldn't be itself. And it shouldn't be dead. All right, so let's continue. And I wonder... Okay, so they rotated. Huh. That's very interesting. So random stuff doesn't really do anything. What if we also spawn them in a random state? Huh. How many genes do we need to have? Genes count. Let's think about it. We need all possible combinations of states and environments. Yeah, it's kind of strange. So I suppose their genes just don't do anything in this particular situation. We can try to drop, to dump one of their genes. Do we keep dropping the frames? I'm really sorry. So it's kind of strange. Welcome back, Avnay. Drops should be shutting down your internet. Okay, we dropped a significant amount of... Oh shit, oh my god. I don't know what is going on. Refresh the page, by the way, because otherwise you're gonna have a delay. So yeah, we're back. Welcome back. Refresh the page. It's quite important. Refresh the page. Let's do the following thing. I think I want to just commit whatever we have, and then try to debug the generated genes. Right, we're gonna try to debug the generated genes. So what did we implement here? Random action, yeah. Implement random genes generation. There we go. And yeah, we're gonna push that right into the repo, and you can check out the source code of the thing that we're developing. Right. The source code of the thing we're developing. What am I thinking about? So let's implement a function that prints the chromosome, right? So where's the chromosome? So I kind of want to split all of that into like separate modules, because we already have a lot of code here, do we not? Oh, we have like 500 lines of code. Jesus Christ. Anyway, so where's the chromosome? Chromosome. So we're gonna implement something like print chromo. We're gonna accept the chromo. And for the chromosome, what we have to do is just render its rows. So for this thing, I'm iterating through all of the genes, right? So here are all of the genes, and here we're gonna print F. We might as well actually accept the stream where we're gonna print this entire thing, right? So we can use fprintf. So if we want to save to a file, we can save to a file. So the state. So first thing is the state, chromo state. Next thing. Next thing is the environment. So we're gonna have a function environment as sister, right? Environment as sister, and we're gonna do chromo environment. Alright. Next thing is oh boy, action, right? So this one's gonna be action as sister, chromo action. And the next one is going to be the state again, but it's the next state. It's the next state. So there we go. This is how we're going to print all of that. And of course, I forgot to have a new line there. So we need to implement all of these functions here. So for the environment as sister. Const char. Environment as sister, so we're going to do env, and what we need to do here is essentially just you know, switch upon all of these things and just convert them to a sister. Sister means C string, that's what it means. Okay. So then I'm going to replace this thing with that, then I'm going to replace this thing with that, And I suppose I can do like this. We're going to simply return that. But what's fun is that in case of a count, I think we should assert, because count should never happen in my opinion. Right, there we go. So in case of a count, I'm going to say assert unreachable. Unreachable. All right. So another one is going to be action as sister. Right. Action as sister. Let's quickly do that. Action as sister. So it's going to be action, action, boom, boom. Switch, 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 switch. Action. There we go. There we go. Replace this kind of thing. And case. I'm gonna do it like that. Return. Boom. Boom. This one is also unreachable. Let me actually first do something like this. No default case. Yeah, I could add default case, but I mean, this switch case is actually exhaustive, so there is no need for default case. Unreachable. Okay. So we have chroma state, and of course, I'm being me. Forgot this thing. Do we have anything else? Construct has no member state. Oh, this is because I see. So yeah, we have to iterate through the genes. Yeah, genes. There we go. So now it will work. So when we have a couple of, yeah. I mean, why do you say it's unreachable? I'm checking all of the... All right, that's really strange. Maybe in that case it makes sense to add unreachable. Hello, Locopadro, welcome to the stream. Hello, hello. So, and default is going to be just that. Yeah, it's quite important to like assert for the rest of the things, because yeah, count is not a valid value. It's a hack to know how many elements we have in enumeration. So in my opinion, it's quite important. Okay, so it rotated once, but that didn't do anything. All right, so now we know how to print chromosomes. I want to try to print, after we initialized everything, I want to try to print the chromosome of the first agent, right? So, and of course we want to do like a static assert that agent's count is greater than 0, otherwise it's not going to work. Then print chromo game chromos 0, right? And we also have to provide, let's actually print to std out and pointer, and let's take a look at the chromosome. Not enough agents. There we go. Chromos. There we go. So this is what we got. So this is the random chromosome here. I have a feeling that we have too many states. That's what causes the situation. So essentially, the initial state is 0. Okay. So an initial state of 0, if you have an agent in front of it, you have to try to eat the agent and then switch to the state 10. And in the state 10, if you see a wall and stuff like that, I think the problem here is that we have too many states. So maybe if we had like 5 states, 5 possible states, it would actually build up enough redundancy so it will start to behave at least. You see what I'm doing here? Kinslayer, thank you so much for 15 months. Thank you so much for 15 months of tier 1 subscription, and welcome to our epic genetic club. That's right, look at that. So this is the chromosome of a single agent, right? And so the problem is actually quite obvious in my opinion. The problem is quite obvious. We have too many states. Let's actually introduce the amount of states. Like let's just cap that. So we can have states, but it kind of like limits what kind of solutions we can have, right? So doesn't allow us to add more states in the future. No, we'll see. Let's see. Okay, states count, and let's say that we're gonna have 5 states. Why not? 5 states. And when we initialize in the game, and instead of using genes count for the amount of states, we're gonna have states count. This is not what I wanted to type. I wanted to just type count. Right, let's try to recompile all of that. And it didn't compile because it's states, not a single one. It's multiple of them. And now we have less amount of states, and we have a little bit of redundancy. So we start at 0. And if we see nothing, we're gonna try to turn left. So some of them will start doing something. Okay, let's see. They're actually doing, and then they stopped. They actually stopped. Interesting. Let's actually regenerate everything. Well, at least some of them managed to generate a loop. Well, what's funny is that we don't have like enough things to actually do anything. And why did it move like that? Like it's not supposed to move like that. I think I did a fucky wacky somewhere. That's for sure. Yeah, especially with rotating and stuff. So triangles are moving, yeah. That's pretty cool. What if I have like more of this shit? Because we're gonna have more different combinations and stuff. So let's imagine that we have a board, like 30 by 30, and amount of agents is gonna be 10. This is gonna be 10. What if I have like 30 agents? Can we have that? I think we should be able to have that. Yeah. Some of them are doing things. Majority of them just actually rotating from time to time. So what if we have like more of them? I think like for all of that to have effect, we just need to. Oh, look at that one! Look at that one! What the fuck is it doing? And obviously, like, there's something wrong with the rotation. Okay, so some of them at least doing something. Maybe we need to, yeah. They probably don't have enough environment. So if we have like 60 of these things, they can probably see more stuff. Huh. Yeah, they're usually stuck. Two agents were in the same place. Yeah. So maybe we should not allow to move the agents to. Huh. Spinny boys. Yeah, they end up spinning actually a lot. So if we limit amount of genes, right? If we have like 10 of them, so is it gonna introduce something more interesting? No. All right, we obviously have a bug with rotating, right? With turning left and right. So there's something wrong there. We'll have to debug that first. Before I go into that, I want to commit whatever we have and make a small break. And then after the break, we're going to continue debugging that. And I think we're already starting to have something interesting. Yeah. All right. So implement chroma sprinting, and we're going to push that right into the repo. So the source code of the repo is available here for anyone who's interested. So, and I want to make a small break, like 3 minutes break, because I need to refill my water and stuff like that. So yeah, small break, 3 minutes, no more, no less, hopefully. I don't know, we'll see. Then I'm gonna go to Zozin Suvun, and yeah, boys and girls, let's make a small break, and you guys have fun. Yo, welcome back. How everyone's doing? Welcome, welcome, welcome. So yeah. Did I push everything? I feel like I didn't push anything. I didn't see... Okay, so it was actually properly pushed. Nice, nice, nice. So what I'm thinking about is that I kind of want to separate... so I didn't miss the best content, did I? Oh, yeah, I see. Thank you. Thank you so much for the content. All right. Yeah. I want to kind of make the state of these things a little bit more visible. Yeah, that's definitely something I want to make. So, and also, I think I want to separate a lot of this stuff because we have too much code in a single file. I really like that. I really like that. So what I'm thinking is that I'm going to introduce like a thing called game, right? So which defines the rules of the game. And then we're going to have like a rendering, the visualization part. And then we're going to have a third module that is responsible for genetic algorithms. So I'm going to do a little bit of a refactoring here super quick. Hopefully that will turn out well enough. So I was having a lunch. What happens? Did the step work? It actually kind of works. As you can see, some of them do things. Some of them can go forward, and yeah. But they end up just rotating around, which is not actually quite good. Do you implement genetic hunger? No, I don't implement that. So far we have that, but the code is a little bit big right now. So what I'm hoping to do right now is to, you know, refactor it and rearrange it a little bit. So let's do that. I'm going to use like a single compilation unit. First, I'm going to create a separate folder for this kind of stuff. I'm going to move everything there. And we're going to have like this thing, GP main, then GP style. And then we're going to just have a GP, which is going to be the single compilation unit, which simply includes GP main.c and any other translation units that we're going to have in the future. So for all of the dependencies here, we're going to just include that, but maybe it actually depends if we want to include that here. Yeah, I think we're going to include that here. I think I want to make them available for like everything. All right, so, and now, when I make this thing, I want to make this thing dependent on everything inside of the skin for the agent when. I was actually thinking to change their color to indicate the hunger. Right, maybe the more hungry they become, the less saturated they become, so we can see the like a little bit easier their state. So we'll see, but maybe we're gonna have some sort of like that. So next thing, I want to see how I do that in something. I need to grab all of the files inside of a folder, and I don't remember how I did that. So yeah, it's a wildcard. Yeah, it's a wildcard. It's a very wild card. And then do something like this. Wildcard src gp. I'm actually taking like, I think I want to take all of the files from there that start with gp. And the only thing I need to build here is essentially gp.c. Might as well actually like all files from src. We depend on all files from src, and then we just compile everything. Okay, let's try to compile everything one more time. And this thing has to be gp. Yep, and it worked. So we introduced a single compilation unit. So now we can easily split everything. Introduce single compilation unit. All right. So the next thing is going to be introducing game and rules and stuff like that. So gp game.h. And let's start moving everything there. Everything related to the game. We're going to go to the main. So we have board, right? We have board. Screen and width is not really related to the game, it's related to the rendering of the game, and I want the rendering visualization part to be a completely separate thing, because visualization has nothing to do with the rules of the game, right? So we also have, well, padding also visualization, so it does not belong here. So food also does not belong here. Then we have walls, genes, different counts, agents count, foods count, walls count, blah blah blah. So different stats for recovery also goes here. Then coordinates. I'm not sure if coordinates are part of the game. Let's actually make them part of the game, why not? Coordinates equal. So this is going to be just part of the H. SCC is not related to the game itself. Hex colors is also not related. Direction is related because it's a direction of an agent. Agents deers, yeah, it does make sense, so we're gonna keep them here, and I don't think they're gonna be visible outside. So there we go. Then we have an environment, then we have an action, then we have genes and chromosomes. And then we have the printing of the chromosomes. Game, food, wall, game. So we also have a static assert. Rendering of the game is... render board grid is the rendering, so we also have random int range. Let's create a separate module called random. Is cell empty? Okay, so I'm gonna... Yeah, we'll also need here. Okay, so gp random. So the only thing we'll need here is a random int range. Oh, Jesus Christ.
Cool graphical grid which admire however it just use LIBX11 but that is micros. Platform stuff.
Yeah, I see. Thank you so much, Dennis, for 500 bits. I really like that you like my visualization. What we're trying to do here, we're trying to explore genetic algorithms. So we just implemented a simple, like a Hunger Games, where you have agents that fight for survival. And then we're gonna try to use genetic algorithm to find the fittest one. So yeah. So we'll see how it goes. Right now I'm just refactoring things because the code became quite bloated. So I just want to reorganize things a little bit. Yeah. Alrighty. So let's continue. I want to introduce a separate module where we're gonna keep everything related to random. But to be fair, not quite sure. Okay, so random should be related to the game, yes, because this is the only random that is not related to the game, so it might as well be related. Can you write my DNA too? It sucks. Well, I'm sorry. I'm not a wizard. Or biologist. What's the difference though? So then we initialize the game, coordinate in front of the agent, step agent. That's a lot of shit actually. Wall in front of the agent. Execute the action. Then step the game. There we go. So all of that has to be part of the game. Oh shit, that's a lot of shit. Alright. So everything else is graphical. And accidentally actually moved to render. Yeah, render should not be there. So you can render this thing. And then renderer. Yeah, render agent also should not be there. Well, oh my god, I made such a stupid mistake. Stupid fucking mistakes, man. Render. Okay, so all of the rendering is removed. All of the rendering is removed, which is nice. So it doesn't compile because unknown type game. Okay, that makes sense. So what we need to do here, we just need to do gp game.h. Go. And it does compile. All right. So some of them even do something. They move sometimes, but yeah. Next. So we have gp game, gp main. So I need to now create gp, not gp style, but gp visual. So this is going to be a visualization. gp visual.h, right? Game.h, and everything that, you know, renders. Everything related to rendering should be there. For example, size of the screen, right? Size of the screen, size of the cell, you know, different paddings, different auxiliary functions and stuff like that. So it should be there. And on top of that, visual. Where's my visual? Where's my visual? This is not what I wanted. Why did I open that? Visual should depend. It definitely should depend on gp game because it's visualizing the game. Right, so we're gonna move everything except the game itself here. So I really want to make this refactoring because working with this single file becomes a nightmare, to be fair. So that's why I'm just, you know, performing this, you know, moving things around. gp visual, there we go. So, and to be fair, like, style could be part of the visual. I don't think it makes sense to keep that style because it's such a tiny file. Might as well just put it into the visual somewhere on top, right? Yeah, there we go. So we have screen width, screen height, and then values that depend on screen width and height. You see, all of them are computed based on the screen width and screen height, and here we have a style. Might as well actually go ahead and say this is a style. There we go, this is a style, and we can remove the file style. It's not used anymore, and yeah, there we go. Is it going to compile? And it does in fact compile, which is kind of weird. So we remove the style, we put everything there, and okay, so everything seems to be compiling. So now I want to actually separate that into header and C file, you know, the usual C stuff. So it's going to be gp game C, and that thing is including gp game.h. So, and what goes to the C file? Well, implementations of these functions, for sure. So, so I'm going to copy paste this thing here, and this one is going to be just forward declaration. So this is a forward declaration. The next one, this thing I'm not quite sure. Maybe I'm going to just keep it as an internal thing here. Yep. And also coordinate stuff. Alright, so these are the type definitions of some sort, and this is the implementation of the function. I'll put it here as well, and this one is going to be just a forward declaration of that function. So this is implementation of another function. This is going to be forward declaration. So print chroma. So do we even have chroma? Okay, so game C. Print chroma. All right. Let's remove that as well. All of that are function declarations. So the static assert is quite important, right? It checks the very important variant for our application. If it doesn't hold, we're screwed. We're pretty much screwed. So that's why it's important to keep it here, like that. All right. Zozin, but why aren't you using IDE that does all of that for you? Well, because I'm not very smart. I'm sorry. Okay, is cell empty? Is this a fascinating way to do line numbers, which makes, okay, relative numbers. Relative numbers. There we go. Here's an article for you. That question is actually asked so many times. My god, it's actually unbelievable how many times that is asked. It's just people just see weird numbers and they think, what the fuck is this weird numbers? But there's nothing weird about them. They're just relative numbers. They're just relative numbers. Then why not use my IDE, the best of all? Yeah, I'm sorry, I'm stupid. I'm very stupid, I don't use IDs. That's the shit I have to deal with every day. If I just used an IDE, I would be so productive. It would be mind-blowing. So yeah, I forgot semicolon somewhere here. When will you create your own IDE? I don't really want to. The thing is, I don't need IDE. That's so. If I needed IDE, I would just create it. So I don't know. But Zozin, why not use mesh shaders? You can write, yes. I should just use mesh shaders. What is the language? English. Well, I'm not the best English speaker, but I mean, at least I'm trying. For the personal question, should I email you? It depends how personal it is. Like, it's you actually. I don't know. Well, feel free to email me, I suppose. Why not? I don't mind. How personal is it? How personal is it? You can find email in the panels. I think you can find it. But then you'd ask, what is the language? What is a language? Ah, I don't know. I'm not a linguist. Is there like a it is yeah. Is it about me? Not confidential. Yeah, there should be. Maybe we should actually like have a email command update CMD.
Over a year of the Siberian oil man hacker.
Thank you so much for 13 months of tier 2 subscription. Thank you and welcome to our genetic programming club. Thank you. Over a year indeed. Sortingbiz.gmail.com. There we go. So we're gonna add this thing here, and yeah, there we go. So let's continue, I suppose. I didn't really want to copy this thing. So Siberian Wildman, interesting. I've never called like that actually. Well, it's pretty wild in here, like I'm in the middle of Siberian forest, but this is because I'm an academic doc. I don't know if, like, probably not everyone knows that. How can I get idea about your project? It's just, I'm just experimenting with generic programming, and yeah, I mean not generic, but genetic programming. So we can try to Google that. So the thing is, Akademgorodok. So this is a place in the city of Novosibirsk that looks like this. So yeah, I literally live there. Seriously, it's a Siberian forest. Yeah, it's pretty wild. Also, it's a pretty old photo. I think some of the trees were already chopped some time ago because they need space for building more apartments and stuff like that. So Alrighty. So this is how many functions I defined. Jesus Christ, that's a lot of function. But maybe that's a good thing, because that means I wanted to say a lot. Ganovin Banane, I hope I pronounced your nickname correctly. Thank you so much for 4 months of tier 1 subscription. Thank you, thank you, thank you, and welcome to our epic genetic programming club. How about that? How about that? It's pretty cool. Thank you so much. Really appreciate that. Alright, so does it compile? So we have some stuff here that doesn't... Okay, agents, deers. Anything? Okay, so that means those agent deers, generative programming. Yeah, I think it's called genetic or generative or something, but I'm not quite sure. So I think the visual thing, so this thing should be in the visual part. Yeah. Oh, by the way, I think we should also introduce something like deer count. Yeah, so how many directions we have as well. I think it's quite important. So, and if we go to game.h and we find direction, we can introduce something like deer count, and it will contain how many directions we have there. So, init game. Cool. So where do we... Ah, yeah. So it's actually nice. So now we go into our single compilation unit, and we are including this thing there. So like this. So it's a single compilation unit. We still have undefined references there. I don't quite understand why. Did they... I think I forgot to... Yeah. I forgot to bring them over. Yeah, I think I removed them. I think I straight up removed them. I'm an idiot. I'm an idiot. Alright. PHP Strong, Runtime Igor.
PHP Strong.
Thank you so much for 3 months of tier 1 subscription. Thank you, thank you, thank you. And welcome to our PHP club, I suppose. So, thank you, thank you, thank you. This is super cool. This is super cool. So I'm gonna go back here, and I'm gonna just put this thing here. Hopefully that will do this stuff. PHP Strong. Oh, there we go. So, I think we... Why does it make 2 steps? Something is really fucked up here, by the way. Something... Like, it's not supposed to jump over the cells. Any place you'd recommend tourists to visit in Siberia? I wouldn't recommend visiting Siberia. I heard Novosibirsk Zoo is quite cool. I've never been there, but a lot of people like around Siberia go to Novosibirsk just to visit Novosibirsk Zoo. Also, there's a lot of interesting places in Akademgorodok. I would definitely recommend to visit Akademgorodok for sure. Yeah, maybe the bridge as well. So we have a new bridge that was built like relatively recently, like 3 or 4 years ago. So which looks quite cool, I think. We don't really have that many places. Like yeah. So there should be a bridge somewhere here. This one. I don't know. It's actually okay bridge. It has an interesting design. The design was probably stolen from somewhere, that's for sure. But I don't know. There's not that many interesting places. And the problem, maybe I don't know. I personally don't know that many interesting places because I just don't go anywhere. So yeah. So, and definitely not a tourist or anything. Introvert, yes. I participate in introvert parties, that's all. Cool. So now I want to actually separate the visual part. Go out and get a life. I already have life. This is my life, is it not? I don't know. So, are you saying that this could not be a life? This is my life. You're literally saying my life is not a life. What the fuck? Disgusting. Maybe I like this kind of life, who knows? Maybe that's what I want to do in my entire life. Alright, so this thing is like this. All right, so I'm gonna put it like that. What is this outsiders talking about? I don't know. I've been outside today, actually. I didn't find anything interesting. Right now, outsiding is in a lot of different places, including Brazil. Oh, yeah. The South American Russia. Yeah, so I say that joke all the time, so that Brazil is a South American Russia, because after talking with Brazilians, I have an impression that living in Brazil is pretty much like living in Russia. The same corrupt government, the same crazy culture and stuff like that, so yeah. And Russia is essentially Eurasian Brazil. Anyway. I don't even understand how people live in countries without a corrupt government. How do you get around, actually? Do you actually have to follow the laws? What the fuck? I'm joking, of course. Paperwork. I see. A lot of it. Yeah, it's understandable. Oh, and you're German. Yeah. I heard, like... Yeah, I heard horror stories about paperwork in German. Yeah. Yeah, it's kind of interesting. Because, I watched Life Overflow at some point, and he was talking about like registering a company in Germany, and he said that like it's technically way easier to just buy an existing company than going through the whole paperwork of registering a company, and that spawned like a whole business of companies registering new companies to sell to people who don't want to go through the paperwork, and that's the thing in Germany. Yeah, it's not a stuff for me. Yeah, I can see that. So, very interesting. That's normal in K2. Oh, interesting. Oh, and by the way, speaking of Singapore, I heard that Singapore is super startup friendly. So it's actually should be easier to register a company there or something. Alrighty, so here's the visual part, and let's try to compile it. Welcome back, Isleo. So, and I'm gonna go here, and I'm gonna simply include GP visual. Let's see. What about Japan? I don't really know anything about Japan. So, alright, I separated the whole thing into three modules, into three main modules. So there's the main, which contains an entry point and implements an event loop. There is a game module that implements the logic of the game. There is a visual module that basically implements visualization of the game state. Like it literally has rendered the game and it takes the game from that game, and everything is decoupled, separated. And in the future, we're going to have a separate module that is responsible for training the particular population and whatnot. So, and I think the time has come to do a committee. So that was actually pretty cool refactoring. So, to be fair, I would like to rearrange things a little bit more. So, for example, everything related to random, right, should be in a single place. Now, as you can see, we have all of the random things, right, that generate random. So maybe related to math is going to be here. Coordinate in front of agents. So there's also like a whole class of function called in front. So we can take this class of functions and put them here. So this is in front class of actions, right? Coordinate in front of the agent, then different kinds of things in front of the agent, right? Then environment of the agent, this kind of thing like logically should be called environment in front of agent. I think it would be even cooler to call these functions like that. Like, yeah. Nah, not really. But yeah. So, and now we have everything. So this is related to initialization. And here's the, yeah. So everything is related to execution. Looks good. Looks good to me. So this is auxiliary functions, I suppose. Yeah. So it's actually getting a shape. I really like that. Right, single compilation unit, split the code into decoupled modules. Right, and I'm gonna push that right into the repo. Did not watch the first stream. Are you doing the genetic algorithm in C2? Yes, I'm gonna do it in C2 because I didn't like C1. but yeah, I'm gonna do everything in C because it's kind of interesting in my opinion. All right, so look at that code base. I think it's a pretty neat code base. So everything is, you know, neatly organized. We have separate modules and stuff like that. Everything separated, decoupled, and yeah. So here's everything related to the rules of the game. So yeah, the rules of the game are too complicated. I should actually come up with something more simple, but yeah. Sounds super fun. It is fun, in fact. You can find the source code of the thing that we're developing, like here. Yeah. So also, I'm gonna go to the README, and I think the time has come to start maintaining the hotkeys we have. So we have a quick. Oh my God. THJVecancy. I hope I pronounce your nickname correctly. I'm not sure how to pronounce it, but thank you so much for tier 1 subscription. Your first subscription, by the way. Welcome to our epic genetic programming club. That's what we do here. Welcome, welcome, welcome. Cheers, by the way. So I want to maintain the hotkeys just for, you know, people who want to try out these things, shortcuts. I think this is how we're gonna call them. And I don't remember how to properly random them, so I'm gonna just go to nothing. And I do remember there were these kind of things here. So we're gonna have key, action, and boom. Can your Vim do that? Can your Vim do that? I don't think so. I think it can. I think there should be something like that. So, and what we're gonna have here is generate new state of the game. So this is another thing. I'm gonna have keyboard space step the state of the game. There we go. And I'm gonna go ahead and do a committee document shortcuts. There's not that many shortcuts, but the reason why I want to document them is because now once we have the table where we're gonna maintain our shortcuts, it would be super easier to add new shortcuts as we add them to the source code. You see? Right. So because since we don't have that table, there is no reason to add anything there, but once it's there, why not just add a new shortcut? And this is how it makes it easy to maintain this the documentation, I think. And let's take a look at how it was rendered, right? Let's take a look at how it was rendered. And it was rendered okay. So the markdown engine of GitHub also recognizes KBD tag, and it looks okay. It actually looks pretty cool. Auto-generated from the source code, but that requires like an additional work that I don't really want to do, so I'm sorry. Don't really want to do too much work on this kind of stuff. So yeah, now you can actually grab the source code. If you have these dependencies, you can just build this thing and run this thing. And now you also know shortcuts. You can regenerate this kind of thing. You can step. And let's continue developing this kind of stuff. So we want to debug what's going on, because I think sometimes the agents act really weirdly, and I don't think they should act like that. So what I'm thinking, I want to implement a feature where I could simply click on the agent, and it will dump the state of the whole agent to the to the standard output, and then I can explore what is going on there. I think it's going to be an interesting idea. So it will dump the whole state and the genes of the agent. So let's go ahead and implement that. It's going to be interesting. I'm gonna draw graphs of fitness progress. Maybe. I feel like we're gonna have like a third part of genetic programming, because it's actually getting quite crazy and interesting. So yeah, but I'm not sure if it's gonna be tomorrow, because tomorrow I promised that we're gonna have a game development. So all right. So let's go. What we need to handle here, I think, is mouse button down. You could always continue next Friday, probably. I'm really liking what I'm doing here. It's so interesting implementing this whole system and genes and stuff like that, and then debugging why it's not gonna work. I think it's super interesting. We have a raid from Pilada. Good fucking morning, pilots. How are you all doing today? Welcome, welcome, welcome. We're doing genetic programming. So yeah, that's what we're doing today. It's kind of cool. So not everybody knows what is a genetic programming, but it's basically an optimization technique for finding the optimal solution for a particular problem. Sounds boring, I know, but we're trying to apply it to small Hunger Games that looks like this. So essentially, we have a board, and on the board we have different kinds of entities. And the first kind of entity we have is some sort of agent, like a living entity. Then we have a food that the entity can eat, and then we have walls that are rendered in a very scuffed way, as you can see. So yeah, so that's basically the kind of things we have here. Optimization is interesting and exciting study, though. It is, but some people just find it boring. I don't know. It's not for everyone, that's what I'm trying to say. And essentially, the agents have a limited amount of actions. They can move forward, they can rotate, they can attack to attack other agents, and they can try to eat the food in front of them. So, and we have, for each agent, we have an associated state machine, right? And that state machine describes the behavior of the agent. Thank you so much, El Papig, for 25 bits. And yeah, so it describes the the behavior of the agent. Essentially, the state machine consists of the following thing: what kind of action the agent have to perform in a particular state while seeing in front of it a particular kind of entity. Right, and then what kind of state it have to switch to. So let me show you. So there's a game. We have a structure called gene. So this is the state of the agent. This is the environment, what it sees in front of it. This is the action that it has to perform while being in that state and seeing this thing in front of it. And this is the state it have to switch to after performing the action. Right, and the chromosome is basically a sequence of these genes. Right, it's a sequence of these genes, and each agent has this associated chromosome and each agent has such chromosome associated with it. So what we do, we just generate random chromosome and let the agents like play in an environment, and then we see who's gonna survive. Then we take the chromosomes of the agents that survived, crossbreed them, essentially slicing the chromosome in half and mixing them together, and also apply random mutations. And then we let the new generations of agents again play around and see who survive, and continue that process until we have the fittest agents who can survive and sustain themselves. So that's what we're trying to do here. So far it doesn't work, but that's the plan basically. That's the plan. So right now we're implementing the simulation, right? We're implementing a thing that will simulate the game. Once we have the simulation, we can start implementing the genetic algorithm that optimizes the process. So, and the whole source code is available here. You can check it out here if you're interested, of course. So this kind of things are related to artificial intelligence, right? Quite often genetic algorithms are applied to neural networks, right? Because you can also sort of breed and select like the best neural network with this kind of algorithm. So yeah, I never done that before. This is like my first time doing that. Actually, this is the second stream, but I mean, I haven't done anything working so far. So yeah, there's a lot of studies on this topic. You can just Google genetic algorithms. You'll find a lot of articles and stuff like that, which I haven't read, by the way. So I'm just going off of the idea of genetic algorithm and trying to come up with my own thing. It never ends well, because it's like doing something that you don't know, it never ends well, but at least I'm trying. It's kind of interesting, I think. Yeah, and this is probably why people don't use them anymore, I think. I think people stopped using genetic algorithms because, like, why do you need that if you have like a back propagation and stuff like that? It's just way faster. But again, I also don't know much about neural networks, so I'm really sorry. So right now we have a really strange situation. Some agents like behave in a really weird way that is they're not supposed to behave like. And that's what we're trying to debug here. I'm gonna implement like a very simple thing that lets me click on the agent, on a particular agent, and it will dump the state of the agent, and then we can explore and debug it. So we'll see how it goes. So what I need to handle here, essentially, I know that in R&D work that I'm adjust to, I've been seeing success using genetic algorithms to build better object detection machine learning models. Interesting. Huh. So using GA with NN is much easier than this. NN is just a matrix multiplication and then you change the weights randomly instead of coding state machines. Yeah, I suppose. SDL mouse button, mouse down? I don't remember. SDL mouse button down. Yeah, it's a mouse button down. Mouse button down. Yep. So, and after that, I want to actually print the coordinates. I actually want to print the coordinates just to see if they are not affected by the scaling, especially this thing, the render set logical size. Yeah. So let's see if it's gonna affect anything. So it's an event mouse X and event mouse Y. Event mouse X and event mouse Y. Has no button. I think it's called button. Yeah, I think it's called button. All right. So if I press this thing. Oh shit! It is not affected by scale. This is actually perfect. It is not affected by scale. I mean, it basically rescales the position of this thing for me automatically, which is actually pretty cool. So that means I can just take X and Y, divide them by cell width and cell height, and get the coordinates, which is quite cool. So in GP Visual, we can do something like Yeah. So let me see. So we're gonna take event button x, right? Event button x, and we divide it by cell width, and that gives us the coordinate that we can forfeit. We can floor this entire thing and cast it back to int. Right, and so chord cell, and this is cell x, right? This is cell x, and this one is going to be cell y. So this is y and this is height. So we have this kind of coordinate. So, and then we can do different kind of things there. For example, we already have in a game agent, agent in front of agent. I think we need an additional function. Agent at. Yes, I think this is perfect. Agent at, where you have to provide the game and the coordinate, right? Do we have coordinate? Yeah, perfect. Coordinate, right, and it will return you the agent at that particular coordinate. Yes, and that means these kind of things can be implemented in terms of these functions as well. Shit, that's actually pretty cool. I really like that. So let's go ahead and implement all of this. Yeah, so agent at, and essentially I'm gonna iterate through all of the agents that we have. Agents count plus I, and if game agents I position chord equals position chord. Maybe it makes sense to also call it position. I don't know. It feels like it would probably make sense. So if they're equal, we instantly return the pointer to this thing instantly. Otherwise, we don't return anything. So, and this function enables us with doing like this: agent at cell. And yeah, just a second. You got an update for Chitorina. Yes. What coding language are you using? I'm using C. All right. All right, so here's the agent. If we do have an agent here, what we have to do here is print agent. Jiang, I noticed you. Did you say something? Wait a second. Oh, I thought you just said something. Okay, I noticed you. All right. I thought you said something to me and I missed it. Oh, you did it for fun. I see. I see how it is. See how it is. All right. All right. I'll remember that. So agent. We need to print the agent. Okay. Agent. So, and to be fair, we're gonna have that, and we also want to be able to print the chromosome associated with the agent, but it's kind of, it's detached from the agent. God damn it. Yeah, I should probably also take the file. Why not? Yeah. All right. Game C. Printing the agent. So we have a position, direction, hunger, health, state. The problem here is that we don't know its index, right? We actually don't really know it, but we can easily calculate it. Essentially, how you can calculate the index of this thing is you can take the agent. If it has something, you can take the game agents and essentially do something like this, and that will give you the index. Well, it will give you... Yeah, it will give you the index essentially. But yeah. So let's just also do std out. Printf, and we're gonna do something like agent, and just close this entire thing. No. Game HPP. So we're gonna have a position here. Position is gonna be this thing. Alright. Then we have a direction. This one is gonna be S. So the next thing is gonna be hunger. It's gonna be D. Health. And state. And it's also gonna be S. So in this case, agent position X, agent position Y, nothing special. Direction as sister. So then, actually, agent dir, agent hunger, agent health, agent state. And I think we need to introduce something like... Oh, state is actually this. Okay, so state is actually that. Alright. So is it gonna compile? Is it gonna compile? Do we even have dearest sister? I don't think so. We don't have a dearest sister. Let's implement that. So the game... Where's the direction? I saw direction, I missed it. There we go. So it's gonna be this. Alright. Const char dir as sister, and we have to provide dir blah blah blah. Game cp blah blah blah. And I'm gonna just take this kind of stuff. Yeah, sometimes I do type it. Alright, replace this thing with that. Then switch direction. Oh shit, I didn't replace the commas for some reason. I don't know why. I'm a bibega. I'm a big bibega. Return this shit like that. And then align replace return. Boom. So I think for this case... default assert unreachable. Alright. So agent at, so we don't have an agent at because this thing... Oh, it's supposed to also take the game. I see. That makes sense. Alright, so now also here I don't want to print the chromosomes, right? So let's actually remove that. And now every time I click somewhere, it prints the this entire thing here. Cool. So I think I did a fucky wacky. Yeah, I definitely did a fucky wacky because I forgot a new line here. So if I try to do it one more time here, you see, it doesn't matter what I print. Click here, it doesn't print anything. But if I print on the agent, it shows that its direction is right. Right, its hunger is that, and so on and so forth. At some point, we can click on them again, and we can see that their hunger is decreasing. Right, and at some point, I think they should become dead. And we have a bug that we don't, for some reason. Yeah, also hunger can become negative. So we still render dead dead bodies. So this is actually a problem. Don't you need a new line before pause? Yes, I do need it. Thank you so much. Alright, so let's commit whatever we have here. I think we already found a bunch of problems that we need to fix, that's for sure. Implement dumping agents state on clicking on them. So that's basically what we implemented here. So now we can click on the agents and that will dump their state. So shortcuts. Let me actually change it slightly. It's gonna be keyboard, right? So this is a keyboard. Keyboard. Okay. So mouse. Clicking on agents, red triangles, dumps their state to std out. So this is basically what we have here. Document agent state dumpling, and agent state dumpling. Wilkins, hello, welcome to the stream. Keyboard. Alright, that's super cool. And then there's a dumpling. It's kind of dangerous being a dumpling on my stream, considering that I eat dumplings every day. Be careful if you're a dumpling. Alright. I don't know. We'll see. We'll see about that. We'll see about that. So, you need a hug. I can give you a dank hug. Free for dank hug. There we go. You got a dank hug. Dank hug. English is hard. Two. Alright, so we can click on that. And first thing I want to fix, by the way, I don't want to render. I don't want to render dead bodies, that's for sure. I want to render dead bodies. So let's go to the visual part, and when we are rendering this thing, so render the game, render the agent. If game, are you gonna dump their state tables too? Yeah, I'm gonna dump them as well, sure. I'm in the middle of implementing all of that. Agents and health is greater than 0, that only then we're gonna render them. That's right, so that's quite important. So now we're not gonna render them. The foods are not rendered, they are rendered. I think I forgot to do that. So, and here, I think if game foods eaten, if game foods is not eaten, I'm gonna do it like that. Make sure you also stepping. Yeah, I think it makes sense. Yeah. Thank you so much. Step agent. Yeah, there we go. It's actually step game. I think it's closer to the step game. Yeah, we essentially have to ignore all of the dead agents. That's for sure. We should not forget. And it's kind of easy to forget. I don't like how easy it is to forget to do that. So maybe I'm actually not doing that in a really good way. But, yeah. Health is greater than 0, only then we're considering their state tables and stuff like that. And essentially also here, we have to ignore them as well. And to not, to simplify things, I might as well actually handling their hunger here. So we can just remove this entire stuff. So might as well interpret genes here, then apply hunger. And I feel hungry, by the way, right now. I think the hunger got applied to me. Why not delete dead agents? Because we don't have a dynamic array. We have a fixed array, and we're just marking dead agents. And implementing it the other way means I'll have to spend time on that, and I just didn't spend time on that because I spent time on something else. Does it make sense? Does it make sense? I think. So usually the question to why I didn't do it the right way, because I was just doing something else the right way, because I have a lot of things to do. So yeah, but I'm thinking about that actually. So let's actually step a couple of times. Step a couple of times until all of them are dead. So they actually get died simultaneously. It's kind of funny. Yeah. All right. Starvation. They all starved to death. Nobody managed to sustain themselves at all. All right. So ignore dead. Yeah, they figured out how to move in circles. It's actually quite interesting. Maybe make them transparent or gray color if they're dead. Not a bad idea. So ignore dead. If I'm gonna do that, so here's the visual part. Render agent. That means I'll have to move that inside of this thing. Agent color. So we need to replace it like that. So visual.h. So we have an agent color, agent alive color, and we can have something like agent dead color. So what's going to be the agent dead color? I think it could be something like grid color. I think I'm gonna make it grid color. Grid color. So also my OCD kicks in. I really apologize for that, but I need to fix that super quick. Well, what the fuck? Alright. Agent color, agent alive color, right? Agent alive color. Alright. And so we can actually do something like this. uint32 color. So, and if the agent health less than or equal than 0, then we're gonna have agent dead color, otherwise agent alive color. Alive color. And this is what we're gonna use here instead. There we go. Excuse me? Oh, because this thing is not pointed. Alright. So they're rotating in circles. And at some point they just dead. Oh, because I didn't remove that condition. Yes, if I remove that condition, it should be better. Yeah. Wait a second, this is kind of weird. This is not the color that I expected. This is such a weird color, what the fuck? I expected like a bluish color. But now I'm not quite sure. Wait, why did it not complain? Why did it not complain that I'm using the wrong thing? Because this has to be like a hex color thingy and all. Oh shit, is that the... Oh shit, I see. So, okay, so this has to be RGBA. So now, if they're moving around and shit... and then they get dead, but they look like the walls, so it's not particularly great. So we can actually make it like a background. Hello, Rayfied. So I want to kind of make it like a background, but slightly like 50. How about that? This thing looks super weird. It's not supposed to even do things like that. Alright, so they're kind of grayish now. But they could be even like slightly brighter, I think. Could be. Maybe 90. Let's give it a try. Bike shading, by the way. One agent, yeah. It's a good one, I think. I think it's a good one. Yeah. Alright. So what did we do here? Handle dead agents properly. So I'm gonna push that right into the repo. Yeah, it moves really weirdly, and it feels like maybe the step agent is falling through somewhere. Like, okay, so there's no falling through anywhere, but it's just weird overall. Ah, I know what is going on. I know what is going on. It goes through all of the genes, but what it has to do, it actually has to stop and switch to the next agent. Oh my god. Okay, that actually makes so much sense. Yeah. So after that we have to break, actually. Yes, we have to break. So once we found the combination that does the thing, we have to break. That's why they act so weirdly, because they get executed several genes in a row that fit. Let's go with the scope and add CSS styling to the UI. We can rewrite this entire thing in Electron, and we'll get a CSS styling for free. But I'm not going to do that because it's boring. So that actually explains the situation, because it get executed several genes simultaneously. If they order their state table correctly, they could do multiple actions per step. Yeah, probably. Sometimes I literally hacked and got more powerful. I don't know. It's funny how this thing got in front of the food and doesn't know what to do with it. And they got dead. Did you saw that one? That actually waited one step and made another step. This is because it had a loop in states. So in one state, it had do nothing and switch to another state, and in that state do step and switch back to that state. That's why, oh my god, it's so cool. I really like that. Alright. I wonder if you can even do something, I don't know. There's two in the same position, top left, and that is even legal in 2020, I think so. Alright, so fix the bug in the gene interpreter. There we go, I'm gonna push that in right into the repo. Fix the bug in the gene interpreter. Alright. I have a feeling that we just need to generate more shit. So I'm gonna go ahead and actually increase the amount of stuff, amount of agents we generate, and see what's gonna happen. So game.h agents count. So what about 100? What about 100 agents? Is it gonna compile? Nah. They're not doing anything interesting. Look at that one. Oh shit. and they're all dead. 100 by 100. Yeah, I think we need to increase the size of this thing. If we're gonna increase the size, I think we should remove the grid. Right, render the grid, because it's gonna only get in the way. Where do we use it? Oh, it's done in the main, so let's actually remove it here. Sebania, welcome to the stream. Okay, so if we're gonna have a lot of these motherfuckers, I'm going to yeah, 100 by 100. 100 by 100, and how about 200 agents? And let's see what's gonna happen. Actually, it's not that many of them. One of them is just moving forward, and let's actually increase the amount of agents. How about like 500 of them? Eventually we're gonna get the one that can survive for a while. I think we should be able to get one. What about 1,000 of them? 1,000 agents. I have an idea. I don't know. So maybe we should remove the food. Maybe they should each eat each other. The food is more scarce now. Yeah, it's true. So let's actually add also more food. 1,000 of food. Some of them will figure out how to eat food. None of them figure it out. Some of them eventually should figure that out. Wait, I think we saw somebody who actually did that. No, I didn't see anyone. More agents? How about 2,000 of them? I think some agent actually adds something. Yeah, I think they're starting to survive at some point. Yeah. All right. So you could log when some of them eats. I also want to keep track of the their lifetime, for how long they survived. Just one agent died before the rest, which is actually quite cool. That means they ate something. We can then take that one agent and you know, make a new generation out of them, and that new generation may be actually doing something interesting. So we need at least one that survived a little bit longer, right? The one that learned how to eat at least. So that would be interesting. So I'm not gonna like do automatic breeding and cross-fitting and stuff like cross-fitting. I'm gonna just actually do that manually. So we're gonna have a separate action for just gather the best things so far and generate a new generation out of them. I think that's gonna be the thing. Doesn't that kind of evolution takes crossfit? I'm crossfitting my genes. What's that supposed to mean? All right. So far, I think it looks interesting. What I want to do, I want to create a new action. I want to go to the game, I suppose. And in the agent, we're going to introduce something called lifetime. Basically, lifetime is going to be how many steps this thing survived. I think another problem here is that the rules are overcomplicated. We have the whole notion of food, attacking, and stuff like that. So I'm thinking maybe we should remove the notion of food and just let them attack each other or something like that. Yeah, we'll see. So for now, I'm gonna introduce the food, and when I'm initializing the game, init game, Another thing we're initializing here is essentially game agents I lifetime. It's gonna be 0. To be fair, I might as well actually do slightly differently. Are attacks insta kills? No, they actually damage. So yeah. Step game, and every time we step a single agent, right, we are increasing the agent's lifetime. We are increasing the agent's lifetime. If it doesn't get increased, that means it's dead. I mean, if it's dead, it doesn't get increased. All right. Cool. Maybe get rid of an attack action and make moving into an agent an attack. Could be an interesting idea. So the main problem right now is the complex rules. The rules are too complex. We need to simplify them, and this kind of thing can simplify it. So we'll have to work towards that. For sure. I'm not sure how the entire thing affects the quality of the stream. It's probably horrible. But yeah. So we're increasing the lifetime, and I think I wanted to do. I'm gonna go to the main. And case is the key next. Dump best. Yeah. So essentially, what this function will do, it will sort them by their lifetime and maybe dump their stats. Then we're gonna actually replace this function with generating a new generation with the genes of the best generation. Right, that's gonna be the idea. But right now I want to just learn how to do this kind of thing, and unfortunately I'm super fucking tired. Okay, so here's the thing to do. Introduce action that manually generates a new generation. So this is going to be to do, and then in the game itself, I'm going to put the following thing. We need to simplify the rules of the game. Remove attack action, make moving towards agents and attack, remove eat action, make moving towards food, the eat and eat. Right, and etc. So we need to simplify the rules so it's easier for the agents to adapt to this kind of situation, right? So do we have any other to-dos here? Do we have any other to-dos? Make agents drop food when they die. Yeah, we need to simplify the rules, introduce action, the manually generate a new generation. There we go. So yeah, essentially the idea of this thing, take the agents that survived longest, 2-3 of them, yeah, cross over their genes, mutate, make a new generation. There we go. So basically we're gonna just step several times until they all die, or at some point that we like, and we're gonna manually trigger next generation, and all of that needed just to test how things works, right? All of that needed is just to test how things works. So mutate. All right, so, and of course, I don't really want to comment this thing, right? So commenting this thing is kind of meh, but yeah. So, did I introduce lifetime? I think I did introduce lifetime here. So it doesn't stage it. It's already staged. Okay. Lifetime. I did increase it. Introduce lifetime. Outline the rest of the work. Right, I'm gonna push that right into the repo. So yeah, outline the rest of the work. So far, I'm really interested in this project. I really am. It's not as like I do not progress as fast as I would like to, but I'm developing everything on the stream, and it's looking so far very interesting. I want to continue doing that. Zorkenheimer, welcome. Welcome to the stream. Thank you so much for 2 years. It's been 2 years. It's almost like I discovered your streams only yesterday. Thank you so much for tier 1 subscription for 2 fucking years. And welcome to our epic genetic programming club. About that, we're doing genetic programming today, so we're trying to, you know, implement little Hunger Games. So the red things here are the creatures or agents that can attack and eat. Green things are the food, and the blue ones are the walls. And they have their small little brains that dictate them how to move around and do things. And these small little brains are basically the state machine. It's a state machine table. What we do, we treat the state machine table as a chromosome in terms of a genetic algorithm, right? So in genetic programming, you have a chromosome, which is a string, and you just calculate fittest function for this chromosome, and then you get the best chromosomes and you cross over them and mutate them and generate a new generation, make a new generation, and you repeat the process until the function converges. And that's what we're trying to do here. So the fittest ones are the ones who survive the longest. So yeah, we're just in the middle of implementing that. This is the second stream we're implementing all of that, and it's going quite well, actually. It's quite interesting. You wanted to play with that. It's actually very interesting. I finally found an opportunity to play with that as well. So it's pretty cool. The creatures themselves, they have their particular state. They have health, they have hunger, they have direction they're currently looking at, because as you can see, they're triangles. So the triangle like indicates their direction and stuff like that. The actions they can perform, they can turn left, turn right, move forward, attack and eat, but we want to get rid of the attack and eat because they complicate the system and the agents do not generate properly. So yeah, what's the difference between env and state? Environment is the entity that the agent can see in front of it. What kind of entity? You can actually take a look at it. I mean, the definition. Let's take a look at the definition. Game.h. Game.h. I usually don't use branches when I'm prototyping the project, right? When I don't really have something established yet. Right, after I have the code base established relatively well, only then I'm starting to use like feature branches and stuff like that. So I'm not sure if it makes sense, but yeah, this is my process. Because branches make sense when you know what you're doing and you have issues. But when you don't have issues, there's no reason to have branches and stuff. Okay, so environment, what's the difference between environment and the state? Okay, state is just a number, right? State is just a number, and it's a state in the sense of a Turing machine. It's just an arbitrary state it can be. We're not supposed to know what that state represents, right? Okay, so I'm going to show you. We have a Turing machine interpreter, and let me actually fetch the latest changes on Turing machine interpreter, because I actually had a lot of changes there. One of the things I did for the Turing machine, I already have the latest version. I added the comments, right? So I added the comments. So in the Turing machine, you have a state the Turing machine is in, then the symbol that the head reads, the symbol that the head writes, the direction where it steps, and the state to which it has to switch to. So, and as you can see, in this particular case, we have a named state. We gave the state the names, so they have a semantic meaning for us because we wrote them and we want to understand what they represent. But in case of the agents in our Hunger Games, I replaced the states. What are fidgets? I'm not sure if I understand the question out there, I'm sorry. But in case of the agents, or did I pronounce something incorrectly? I'm sorry if I did. In case of the agents, I replaced all of the states with numbers, right? It's just an arbitrary number that doesn't mean anything for us. And the reason I did that is because I want the agents to figure them out themselves. So essentially, throughout the random process, they will figure out the combination of states which perform some action, and we're not supposed to know their semantic meaning. We cannot know their semantic meaning. They should figure out it themselves. So does it make sense? So state is just a number that represents some sort of a state. We don't know what it is. They will figure out eventually through a random process. Environment is the object that they see in front of them, and the action is determined by the state they're in and the thing that they see in front of them. I hope that makes sense. I'm not sure, but yeah. Sorry. But yeah. Maybe we can try to make it a little bit closer. Closer to the Turing machine. Essentially, maybe... yeah, it may perform several actions and stuff like that. We'll see how it goes, but yeah. Anyway, hopefully I explained that well. So, I've been streaming for almost 4 hours and I'm really tired, but we had a pretty good progress today. We finally finished the rules that like the first pass of the rule design, and we definitely need the second pass of the rule design because the rules are too complicated. We want to simplify them. Right, and another thing we need to implement the like making new generation, at least manually. And once we have this thing manually, we can try to automate that. But unfortunately, one stream is not enough for all of that. So I suppose we're going to continue doing this exact thing on the next Friday. Yeah. So the next Friday stream is not going to be a random one-off stream. It's going to be continuation of this thing. And yeah, we're going to try to continue doing this thing. I want to take this idea to the completion and get something interesting working, get some sort of result. And I think we can do that. I think we can do that. So yeah, you can check out the source code of this thing that we're developing right now here. And unfortunately, boys and girls, it's time for me to go. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you tomorrow. Tomorrow, according to the skedaddle, we're doing a game development. How about that? People who wanted to watch a game development today, join tomorrow. We're gonna have a game development. We're gonna continue developing our I suppose to type next. We're gonna continue developing our game in C++. Also check out our schedule page for more information on different projects we're working on. Also check out our VODs YouTube channel where we upload these VODs like on the next day, so you can watch them using a comfortable UI. And also check out our Discord server for offline discussion with the community. And yeah, so that's it for today. Should we rate somebody? Let's actually rate somebody. We haven't rated anybody for quite some time. So yeah, thanks everyone for watching. That was actually a pretty cool stream. Koshay is streaming. Oh my god, I'm gonna stream Koshay. I don't really care what he's doing, and I don't really care if he's speaking Russian right now. I'm gonna fucking raid him. By the way, Koshay speaks English quite well. If he doesn't speak English right now, just demand him to start speaking English. Demand. Alright. Wait, what? Not join? Oh, Jesus fucking Christ, mate. Rate Koshay _ alright, get ready for the raid, boys and girls. Get ready for the raid, and I see you all tomorrow. Love you all. Mwah.